Welcome back, everyone. We are here for day 8 of the Azure Solutions Architect Expert Bootcamp to prepare you for the Azure Solutions Architect Expert exam, otherwise known as AZ305. For those of you who may just be joining us for this first day, which is the 8th day, you can go back and watch the previous 7 days on our YouTube channel, and I encourage you to do so. As if you're coming just new, the first week we kind of covered those Azure fundamentals and some cloud computing fundamentals. And in this week, we're focused more on our official Azure Solutions Architect Expert training. I do it this way because you can easily pass any of the exams and still not even know what is cloud computing. So I wanted to give you that first week where we dove into the technology and what is cloud computing and how does cloud computing work and what those services actually in Azure are really from an underlying technology perspective, so you understand how they actually work and how you might support them, how you might use them, how you might apply them. So today we're going to get back to the main content. Now, as we've been here, lots of people have been asking questions about careers. So I've got two free offerings for you. Tonight at 5:30 p.m. Eastern Time, or 30 minutes after we finish today, we're going to hold a special Zoom session. I've not only been an architect for 25 years, but I've spent more than 2 decades helping people get their first tech job, get promoted in tech. And just today, another student told me they just got 2 brand new job offers, and it'll be their first tech job ever. So I love doing this. I love getting people hired. And, there's only so much we can do in a YouTube window, but, we have the ability on Zoom. You can ask questions, we can have a dialogue. And the better information I have, the more I can actually help you. And I really, truly want to help you. So tonight, we've got a special Zoom question and answer session. Tomorrow at 11 a.m. Eastern, we're also going to have a free webinar on how to become a cloud architect or a solutions architect. And we'll talk about what is the role, how you can get hired when you have no technology experience. And again, it happened again to me today, and it happens all the time. And you can get your first architect job, no problem, or any job you want for that matter, if you get the right set of skills. And we'll go over the role. We'll go over what our employers are looking for, so you actually know what skills you actually need. We'll give you the strategy of when you have less technology, the places experience or none, the places you need to shine to show the hiring managers what's so good about you and why they need to talk to you and why they should hire you. And then we'll go over the complete skills list. And I'm going to tell you, most of these skills are actually not tech skills. I mean, there's a good set of tech skills that you need to know, but there's a tremendous amount of business acumen and soft skills. And those are the things that separate you from everyone else. And those are the things that are necessary to be an architect. Because how do you optimize your client's business if you don't understand business? And if you can't build and lead these architecture teams, you'll struggle. So we will cover everything here because I want you all to know how to get the best tech career. And if you train with us, obviously we cover 100% of these skills. But if not, and you want to train somewhere else, that's fine too. I just want you to know everything that you need to learn, so you don't go and get a bunch of certifications and spend a year or two of your time and have none of the skills needed to get the job. And then someone like us has to retrain you from scratch. So I just want the best for you. So there is that. Now, also, if you're joining us and maybe your goal is to be, say, a cloud admin or someone that's working more in support, and I don't recommend cloud admin jobs for lots of reasons. We can talk about that tonight. But maybe you've got a more technical role, like a cloud engineer or a DevOps engineer. Well, there's a certain set of skills for that, and a lot of those are hands-on skills. So we architects don't touch the technology, but those hands-on technology professionals do. So we've got a complete suite of hands-on Azure labs that I'd love you to go through. So go sign up for them, do them on your own time, and by doing it this way, we can focus on what we really need to accomplish, explaining the technology to you. Because when it comes to an interview, nobody's going to ask you to build it, but they are going to ask you to explain it. So that's where most people fail the interview, and all the interviews I've done of technology professionals over the years. So there's that. So if you're new, join us. Tell a friend to go watch these videos. I hope they enjoy it as well, and I hope that these free training sessions can help so many people in their technology career. I'll begin in about a minute. Let me know where you are actually from. I always like this. I'm in Port St. Lucie. I know Chris is in St. Petersburg. I know that Chow is over there in Dallas, Texas somewhere. I know Mark is somewhere in the Tampa type region, somewhere near Tampa, but a little further south. And there's that. And also, hit the like button, and I'll know you are ready when I see where you're from and I see the hashtag AZ305. So Alpha Z 305. And if we're going phonetic alphabet, it would be Alpha Zulu 305. Okay, I'm starting to see some of you all are awake. Jersey City, India, Phoenix, Mohammed in Somalia. I want to see these beaches in Somalia. They always look so beautiful to me. I have to take a trip there someday. It's definitely on my places to go. Southern California, Angela. I like this. Belgium. I've spent a fair amount of time in Belgium. New York City for George. I actually worked in New York City for a period of time. I still keep a place in Princeton, New Jersey, actually. Although it's been a long time since I've actually gotten there. So if you're enjoying our content, hit the like button, subscribe to our channel, and hit the bell to be notified of new videos. And Ottawa, haven't been there, but I used to go to Canada, Ottawa all the time, but it's been a little while. All right, so we're going to begin by talking about landing zones. So Azure landing zones, they provide an infrastructure environment that you can host your workloads. And the key is they typically ensure that your foundational principles are in place before you deploy things. And it's kind of similar to the way utilities are available before you build a new home, say your water, your gas, your electricity. And all these things that you might need are built in, like the network is there, the identity and access management systems are there, policies are there, and your monitoring and the ability to monitor systems. So some things to know about landing zones. And remember, in this section, we're talking about governance. And when we get to other sections, we'll talk about some of these same technologies, but with different use cases. So things to know about landing zone is regarding management groups and subscriptions, which we talked about a lot yesterday. Landing zones are going to be defined by your management groups and your subscriptions, and they're going to be designed to scale for your needs, specifically for the business needs and the business priorities. Now, regarding Azure policies, they're associated with landing zones to make sure that your organization stays compliant with its organizational needs. And much of the landing zones can be pre-provisioned through code, basically streamline that setup place. And that's why I say don't try to train to be a cloud admin, because one DevOps engineer with infrastructure as code can literally replace 100 admins doing these types of things. So think about that as you structure your career. And landing zones are quite scalable. So a landing zone can support an application's migrations, and it's designed to scale across the organization's entire IT portfolio. And there's this concept of a landing zone accelerator, and that can be deployed into the same Microsoft Entra tenant for existing Azure architecture, and it provides kind of an Azure portal-based deployment. So some things to consider in your landing zone design are going to be the following. You're going to use landing zones as part of your overall Azure infrastructure design. We're going to use subscriptions as a unit of management and scale. And that way we can kind of align these subscriptions to some degree with business needs. Now, much more of this is related to your business processes and optimizing business processes, but more than, say, a policy or anything that the cloud provider is doing. But it's designed to assist a business. And because we can apply Azure policy, it can provide some guardrails to make sure that people are doing things in compliance, the right kind of systems. And you'd be surprised. Early in my career, I remember when I was a network engineer for 3 months, and then I got out of engineering and moved straight into architecture, which was the best decision I've ever done. And they called me Sniffer Boy. So if you're familiar with the protocol analyzer, we used to call them sniffers. We'd plug it into the network and you'd see what was going on. And for a little while, I was literally running around and plugging into various ports, VLANs in the network via something called the span port. And I was finding out, this guy's hosting a backdoor web server. This lady, she's got a Napster server serving me Linux. This person had some illicit website that they were hosting from behind the corporate network, and all kinds of things that you might actually find. It was long before, we had good security and good firewalls, and it was at an internet service provider, so they had good access to the internet. But, these kind of things are really what we're talking about. Preventing that. And, landing zones are going to, generally speaking, created through code. So Whether you're using ChatGPT or Claude 3.5 to create a Terraform script to do this, or whether you've got an engineer at your company that's kind of doing this, the point is you can deploy a lot very fast, but for the most part, without even using any of these inefficient management consoles that you actually have. So let's talk about some more things to consider when using landing zone accelerators. Provide it's going to provide a full implementation of your conceptual architecture, and it can include some basically opinionated based configurations for key components like management groups and policies. Now, if you're going to use these landing zones, really the key is to get the business to focus on application-centric migrations, as opposed to a lift and shift where you take your virtual machine in your data center, which is working quite perfectly, you move that same virtual machine to the cloud, and now you pay more for it, and you've got additional latency that you didn't have when it was in your data center. So it's a way to actually make it more of a cloud native, as Azure native type solution. Let's talk a little bit about transition existing architectures in Azure landing zones. And honestly, please believe me, this goes way beyond this. These transitions are going to take 6 to 12 months and 15 to 50 people to even think about what you're doing. But you've got a certification. I've got to give you the certification material so you can pass the exam. And that's one of the major differences between certification and reality. They don't actually even match in any way, shape, or form. But we got to pass the certification because we got to get those interviews, right? And certifications will get you an interview, and then your knowledge is actually what gets you hired. So when we're transitioning architectures in, sometimes we want to take advantage of landing zones for things, because we can deploy the Azure Landing Zone Accelerator in the same Microsoft Enter ID with your current environment. We can create new management group structures, and that way we don't have to affect the existing environment. So I know I talked about identity and access management before. We're going to talk about it a little bit in a different context here, because we're trying to follow more that official Microsoft thing. So when we're talking about cloud adoption frameworks, we'll talk about various things. When we talk about technology and design, we'll talk about various things. So if you'll recall, that identity and access management is really comprised of 3 things. Who are you? Authorization, what are you allowed to do? And accounting, what have you done? So when we're dealing with the cloud, we don't have a lot of security compared to what we have in the data center. We can't do any kind of quality of service or network traffic prioritization. We can't do things like private VLANs. We can't do things like admission control, like 802.1x. There's so much that we lose. So when we get to the cloud, we really have to focus heavily on identity and access management, because we're dealing with less micro-segmentation than we ever could do in the data center. So it becomes so much more possible. So while we always used identity and access management, quite frankly, I haven't worked on a system in the last 25 years that didn't have identity and access management. It becomes much more important here. So the identity access management solution we use has to work for the users. It has to work for applications connecting to other applications. And it also has to work with the ability to authenticate various devices that are plugged in, whether it be a notebook. See, in the data center, you can plug in your notebook, and if the MAC address isn't recognized, it'll shut down the port, and you're not given access to the network. Here, we don't have any of these good networking tools. We lose all this great network security. So we need something that's going to recognize your device and say, allow, disallow, allow conditionally, allow something. So kind of hope that makes sense. So let's talk about some things to know about identity and access management as it pertains to the certification. Let's talk about unified identity management. And that's about managing all your identities and applications in one place, aka Active Directory or Entra ID. And that's why organizations have been using Active Directory for decades for these systems. And whenever we use a good identity and access management system, if we're using Active Directory or Microsoft Entra ID, it should be able to work in our cloud and on-premises environments, which it does. And this, by putting it in a central location, it gives us one system to manage, and it gives us great visibility into things, because it's like that single pane of glass that we talk about. So it's quite useful. And by using the the Microsoft Identity and Access Management platform. And quite frankly, if I was on AWS, I'd still use the Microsoft Identity and Access platform. If I was Google, I'd still be probably using the Microsoft Identity and Access platform, and most enterprises do so. So it's in line with what they already have. So it's going to make life easier. Now, this is going to provide a very good user experience, make it very easy to sign in. Users are already used to logging into these systems the same way. So it'll keep users familiar and comfortable and reduce the time they spend managing passwords. And it's going to increase end-to-end productivity. So we have the ability to do what's called secure adaptive access. And that's really about protecting access to resources using strong authentication. Strong authentication might be you go to log in and you enter a username and password, and then it wants your fingerprint. Or you put your iris into an eye scanner, or it could be a one-time password. So the key here is to use a risk-based adaptive policy. The greater the protection, the more necessary the asset, the greater the leverage of privileges, the more you actually need. So there's that. And by using a single platform like an Active Directory or an Entra ID, it gives us very simplified identity governance. It makes it very easy to control access to applications and data for every single user and administrator. And it gives us the ability to implement automated identity governance to make sure only authorized users have access. Now, we always have to think about the optimal IAM solution. And there's going to be lots of IAM options to choose from. And it's all about picking the right one. So in most cases, we're talking about Microsoft Entra ID, or in the data center or the multi-cloud environment, we're probably talking about Active Directory, but it's kind of the same thing made by the same people, just different branding and marketing names. And Microsoft Entra ID gives you basically your core directory services, which can be application access management, identity protection. It's going to provide identity and access management for the entire employees. And we can use that for our private cloud in a hybrid type cloud environment. Or realistically speaking, we can use an Active Directory server and federate that into the system, and it's still going to work. So in any cases, it's basically what people are already using in the vast majority of enterprises. Now, some things to think about more is business to business. So let's talk about this. Let's say you're a PC manufacturer, right? And a PC, you need DRAM, and there's like Micron that makes DRAM, and there's Hyundai that makes DRAM. Samsung makes DRAM, so lots of companies make DRAM. And if you're a computer company, you may need to access various forms of DRAM. You might also need CPUs, so if it's going to be high performance in today's world, it's going to be AMD. If it's going to be a video gaming CPU, it's usually going to be an Intel system, for example, but not always, because each one of there's back and forth between, who's always the best. You're going to need graphics processors, which that means AMD and NVIDIA. You're going to need hard drives, which means Samsung, potentially Toshiba, Western Digital. So in order to do that, you're going to have to allow businesses to connect to other businesses and see various forms of each other's systems. And that opens a new world of business opportunity. But now, you're now logging into somebody else's system, so that creates lots of security concerns as well. So obviously, we use firewalls and various things that we're actually dealing with. But, the key here to remember is we need a good, strong identity and access management policy. And that becomes extra critical when you're logging into somebody else's systems. So, Microsoft Entra ID, has lots of business-to-business capabilities for these reasons, to allow suppliers and vendors and other parts of the supply chain to, say, collaborate more effectively. We can control how customers sign up, sign in, and manage their profile. And we can use, say, Azure. We can use these things along the way, tailor the sign-in experience, what have you. Let's briefly talk a little bit about Microsoft Entra ID design. So Microsoft Entra ID is obviously the solution on Azure Cloud. It's multi-tenant. So I want you to think about this. If you run your own Active Directory servers, you own these servers and they are 100% yours. If you use a managed identity service like Microsoft Entra ID, it's multi-tenant, meaning hundreds of customers could be on the same server. And theoretically, you're secure, and you should be secure. Unless that server gets hacked and they get access to everybody. Well, that's neither here nor there. We have to work on the assumption that it's going to be secure, but but also make sure that you don't assume that things are secure. And you may want more security should you need more security, like a bank, for example. But we can use it in cloud only or hybrid cloud environments. So we can basically extend the Active Directory on premise via the cloud via connecting these things. And they used to call it Azure. I think they called it, was it Azure AD Connect or something like that? Well, now they call it Microsoft Entra Connect. And that basically can synchronize your on-premise with your multi-tenant Entra ID information. Let's talk about some considerations from a design perspective. So we obviously have the integration between your local directories and your data center and your cloud, and that enables IT teams to manage it from one location. And it provides users with a common identity management platform on there. So sign into something we're familiar with and leverage it across. We may want to actually limit the amount of synchronization we're doing. So we may not want to synchronize accounts with super high privileges across these directories, because in your directory, in your data center, you may have some incredible super users that have access to the ability to take down half of these systems. Maybe you don't want to synchronize that to the multi-tenant Entra ID cloud, because when you think multi-tenant, think Microsoft Cosmos, which has been hacked, and all their users and lots of their customers' information has been there. It's not just Microsoft, all cloud providers deal with this, but just think about that from a multi-tenant environment. Now, we may want to think about password hash synchronization. So we may want to sync the password hashes on the on-premise Microsoft AD to the Microsoft Entra on the cloud. So that's going to protect leaked credentials from being replayed in previous sign-ins. If you'll recall, here's the hash. I put the letter A in, and all of a sudden I get this 256-bit output that I can't figure out. It's gibberish to me. But you can't go from that 256-bit output back to the letter A. But the letter A always produces this, and that means your systems have not been changed. We also may want to think about single sign-in. And by signing in once and having access to other systems, we can enforce a really strong password policy, and we're not going to make our users need 50 passwords. Now, in some ways, that's great. Super convenient, super easy. Unfortunately, if that one password gets compromised, now you have access to all the systems. So we have to consider these architectural type trade-offs in everything we do. But it makes it easier to protect against password reuse. It makes it easier to prevent against poor passwords. And when you have 50 passwords, I've seen it. I used to walk around organizations to assess their security. I used to say I was Fred Flintstone from the Flintstones and see if people would give me access to things, and you would be surprised. I tried that. I tried, we'd go to the inn and we'd ask the receptionist questions and see what would happen, and you'd be surprised what we would get. You'd pretend and say, I'm from IT. Can you help me access this person's computer? And we were all doing that to figure out the level of sophistication that the company had. Obviously, we weren't going to hack them at that point. I'm not an ethical hacker, but you always have to get these things. And these are some of the things that you'd see. But we would see sticky notes on people's monitors every single day that actually listed all the passwords they had for their various accounts. And they'd say, okay, log into this system, username, password, log into this system, username, and password. And that's what we're trying to prevent. If you make it too complicated for your users, they'll find a workaround. So let's think about managing separate identities. We have to calculate the overhead of not integrating our on-premise identity with the cloud, because now we've got two sets of separate identity systems. And that means the opportunity to make more mistakes. I briefly talked about conditional access, but we'll talk about it here in the concept of governance. So conditional access is a great tool with Microsoft Entra ID. And the key is it can signal where you are or who you are or what device you're using. Log in from my primary system that's properly given to me by the company from the right location. Give me access to everything. Now in a Starbucks, or a coffee shop somewhere, reduce access to what I have because it's not coming from a secure IP address. So we should think about with conditional access, we want to get granular with regards to our multi-factor authentication. Maybe we don't need multi-factor authentication when we're in the office, but if you're not, we need something pretty heavy. We also have the ability to do name locations. So if you look at me and you look at what I do, sometimes I go to Philadelphia, sometimes I go to my place in Greece. So you could take the IP address of my home in Philadelphia and put it into a location that's known about. You could take the IP address of my home in Neopatomus, Greece, and put the IP address on there. And you could take the location of my home in Port St. Lucie, Florida. And that way, when I log in from all these locations, they're trusted, and I enter a username and password. But when I go to my favorite yoga studio, Native Yoga in Juno Beach, Florida, well, then maybe it's not my IP address, so maybe require multi-factor authentication, although they have good systems there. So that's really what we're talking about. So, we may have managed devices, and on these managed devices, we have a specific set of applications. We may want to block untrusted source or unknown locations, things like that. Geographic restrictions, what have you. Now, when we start thinking about conditional access, let's talk about things we may want to block. We may want to use blocking to override certain assignments of a user. We may want to block an entire organization during a migration. We want to block certain network applications potentially, or block maybe some legacy authentication things. So we have the ability to block or allow what we want to do. And we may want to block, for example, legacy old school authentication protocols, because we may want to protect against a password spray attack. We may want to think about using what ifs. So we may want to provide some test protocols. So what happens if we do this? What happens if we do this? So we really want to think about our identity protection design. And Microsoft is a tool for that. Again, tools are not the same as humans, but they have an identity protection tool that allows organizations to kind of automate the detection and remediation of what it sees as identity-based risks. And you can further investigate these risks using the Azure portal. We can export various risks. And we can do this to automate the detection and remediation of things. So hopefully that sort of helps. Let's talk about the workflow of this. So administrators can configure risk policies and then monitor for identity risks. And if and when a risk is going to be detected, policies can enforce measures to remediate that risk, maybe prompting a user to reset their password. And then as soon as the user resets their password, because it feels it could be potentially compromised, the risk will be remediated. Some other things we need to think about is related to risk policy detection, and that can identify suspicious actions related to user accounts, potentially in our systems. Maybe it can look for leaked credentials, because Microsoft will check for leaked credentials from various sources. So lots of times passwords get compromised, they get put on the dark web, and this identity protection tool can go look for some of that. It also works with Microsoft Entra Threat Intelligence, and that's going to look for and indicate unusual activity or known attack patterns from the people that are actually using it. We can also talk about something called sign-in risk. And that represents the probability that a given sign-in isn't authorized by the identity owner. So if we start looking at anonymous IP addresses like Tor browsers or anonymized VPNs, we may want to block that, because a serious user is not going to use a VPN that made by a VPN company when they're coming into your system. They're going to be using your IPsec VPN, and they're going to have a real IP address. So there's that. Maybe atypical travel. So it's pretty normal for me and my work environment to go to anywhere in Europe, anywhere in the US, South America, sure, Australia, sure, Hong Kong all the time, Dubai all the time, Saudi Arabia all the time, Kuwait, Qatar. Those are kind of places that I would travel to on a routine basis. But maybe I don't travel to Iran. I just picked a country out of nowhere. But maybe I don't travel to Iran, and maybe we don't do a lot of business in Iran, for example. So if you're seeing a sign-in from there, maybe look for it. Now, if you do business in Iran, then it's fine. You're going to use that, but that's the kind of thing you're looking for. Abnormal, atypical traffic patterns of IP addresses where you're coming from. Also, we may actually see some IP addresses that are basically linked towards various malware systems. So if we're getting sign-ins that are infected with malware that are communicating, say, from a bot server or with a bot server, yeah, maybe we're going to block that too. Or we also can see something called the password spray. And that's lots of attempts trying to sign in with different usernames and the same password. Again, that should spook us that something is actually wrong. So we always have to think about risks. So we should set a high threshold for risk policy. So we need to detect leaked credentials, abnormal user activity, and known attack patterns. Now, the unusual activity is better than the known attack patterns. Known attack patterns means you've seen it before. This unusual activity is Mike's not used to doing this. It's this, it's this, it's this. Think your credit card company. When you first travel, you become an architect, you meet clients all over the world. It's the greatest job in the world. But on that first week, if you leave your house in, say, Palm Beach, Florida, and you go to San Jose, it won't stop you. And the next day you're in London, and it may stop you, it may not stop you. The day after that, you're in France, and all of a sudden you're spending money, and it's like, wait a second, 3 countries 1 week. This is an anomaly. Now, after you do this for a period of time, the bank's AI systems will understand that's normal for you, and it will allow it. So we need to think about what kind of sign-on we're doing. So for things that are medium and above threshold for risk, we want to configure the sign-in policy to medium. And what does that mean? Maybe we do some self-remediation actions like password changes and multi-factor authentication, because that's going to be less impact than just blocking users. And we really need to investigate risks and evaluate risks in the Azure portal. So what we can do is we can take all this information in the Azure portal, download it into a .csv file, and then we can use, say, Microsoft Graph to go look at it and see what we're dealing with. We could pop it into Excel. We can run some calculations on it and graph it there. We can export that risk detection data into other things. There's a Microsoft Sentinel data connector that we can actually do here as well. But the point here is to export your risk detection identities and be able to look at it. Maybe run some AI on it and see what's going on. Maybe just use a visual tool to examine the data. But that's what we're really trying to do. Now, when we're dealing with access, we have to review the design, right? It's not going to be made by one person and people are going to say, yes, I'm so excited about it. So we want to do access reviews and make sure users have the appropriate access. We want to look at what's going on and review the risk by protecting, mitigating, and auditing systems. We want to share our architectures with other experts and maybe some IAM architects. And yes, there are IAM architects which are outside of security, and they can do these kind of things with us. We want to make sure correct user access is actually given, no more privileges, no less. We're going to check access packages and make sure that the groups and the apps and the sites all fit neatly into a single package. So when it comes to reviews, we have to determine who's going to do it. Access reviews typically are conducted by resource owners, delegates, or users. A resource owner is the person that owns that part of the business, typically speaking. And the creator of the access will decide who and what conducts what reviews. When it comes to resource owners, they're typically the business owner. So if you're the senior vice president of a business unit or the executive vice president and you're the owner, you'll have access to this. But you may not be looking at these systems yourselves. You may delegate it to someone on your team. And that's what we talk about, our delegates, when we start working with things. They are a group of individuals that are going to be selected to review these things. Kind of like your executive assistant can actually respond to emails for you because you put them as a delegate in Outlook. It's the same kind of things. And we can give it to delegates, or we can actually give it to end users. And that are users that are going to need to what's called self-attest their need for continued access. And obviously, we can pick multiple reviewers. So when a review is done, we have to set the duration of a review. Maybe it's 24 hours, maybe it's 48 hours. We're going to come up with some, say, automatic actions. We can define them. So maybe we remove access to any user that has been completely inactive for 90 days. Maybe we remove users from a security group that was with dynamic access. Maybe we look at user accounts that have not been reviewed for a long period of time and we tune them as necessary. Of course, we can manually do these things too. And that's really what we're trying to talk about. This identity and access management stuff is really dry. It's really painful. So I'm going to see if there's any questions rather quickly. And if not, I will get back to the content. Other parts are going to be much more interesting. So I'll check here to see if you've got any questions. Similar concept with control tower for Azure landing zones. So yes, Azure landing zones are going to be very similar to AWS control tower. Both provide a framework for setting up secure, scalable, and compliant cloud environments. They both offer best practices from the perspective of the cloud provider regarding governance, security, and resource management. So absolutely, Mohammed. Great question. Great thinking, Mohammed. I'll give you another minute to see. So at 5:30 p.m. tonight, we're going to do a completely free session on Zoom. My team will pop a link to sign up. Bring any query questions you want. Maybe you want to become a cloud architect. Maybe you want to become a network architect. Maybe you want to become a network engineer. Maybe your goal is to be an enterprise architect, which is one of the best roles in the world, at least from my perspective. It's my favorite of all the architect roles, although I love the AI architect role. So any questions you have, you can ask them. You want us to interview you? We're happy to do it. See if you're ready for a job, what kind of job. Just bring us your questions. We'll do anything we can to help you. It's right. And we're going to fit 30 minutes after this, which gives me just a long enough time to feed my cat her favorite lollipops that are made out of tuna and then make sure she's happy. And then I'll come back and answer some questions. My wife's away, was leaving today, so I have to take extra special care of the cat. I'll give you another 30 seconds for questions. If not, I'll get back into the content. And again, I apologize. This identity and access management stuff is dry, but there's a lot of identity and access management on these exams because cloud security is very limited compared to data center security. So identity becomes one of our biggest things that we have to deal with. Okay, well, all right. So let me know you're awake, alert, and oriented then with a hashtag AZ305, and we will get back to the content. So let's briefly talk about what is a security principle. So a security principle defines access policies and permissions for, say, users and apps inside of the Microsoft Entra ID. Application objects and service principles represent applications in different ways. So an application object is going to define the app's identity and settings for token issuance. And it's going to exist basically in the home directory. By comparison, a service principle is service principles are instances of the app in different directories. And they're going to reference an app object and define what that app can actually do for that specific tenant. So let's provide an overview of application service principles. It's basically going to be a local representation of a global application object inside of a tenant. And it's going to be created in each tenant when the app is used. And it's going to inherit properties from the global application object. And it's going to define that application's permissions and its access policies. And as hard and miserable as this content is, Microsoft tends to put a lot of questions on certain exams based upon IAM because they've got a legacy in the world of Active Directory. So let's talk about managed service identity service principles. And they're going to represent managed identities, basically eliminating the need to manage credentials. And it's going to give an identity, it's going to provide an identity for applications to use when connecting to other supported resources. So, and with this, we have to include terms like the client ID, which is going to be a unique ID that's going to be linked to the application itself and the service principal. We have what's called an object ID, which is going to be the service principal object, and it's going to be by the managed identity. And we're also going to have Azure Instance metadata. So what is a service? So what is that? So it's basically a REST API that's going to be accessible from inside of a virtual machine created by the Azure Resource Manager. We also have something called legacy service principals, and that's going to represent legacy applications before the application registers or through legacy configurations. And they're going to have editable credentials, service principal names, reply URLs, and other properties, and they don't necessarily have to have associated application registrations. So a little more data about this is that an application can have only one application object registered in its home directory. And an application can have multiple service principal objects in home directories or different home directories. And an application object is going to have a one-to-one relationship with the software application and one relationship with the service principals. Now, service principals themselves must be created in each tenant where the app is going to be used. Single tenant apps will have a single service principal in the home tenant, and multi-tenant applications will have service principals in each tenant where the app's going to be used. And managed identities can provide granted permissions. So let's think about some considerations when we're going to be using these service principals. So they're going to be created when the app is going to be given permission to access resources. And it's going to be registered in the Azure portal or via the Azure PowerShell or the CLI. And service principals without managed identities are going to be useful for managing credentials, and authenticating external apps are going to be to use service principals to authenticate other apps. So let's briefly talk about what are managed identities. And Azure managed identities will allow Azure services to authenticate with other services inside of Azure or outside, without having the need to manage their credentials or as keys or secrets. So talk about some key features of Azure Managed Identities is from they automatically manage the identity throughout the lifespan, meaning the creation of the identity, a rotation, and or a deletion. They allow for credential-free authentication. So it eliminates the need for hard-coded credentials in code using secure. So you're not going to necessarily want to put your credentials inside of the code of your applications. Actually, you never want to do that. And they integrate very nicely with Azure AD using Azure Active Directory, which in today's world is now Entra ID, for authentication, enabling role-based access control. The point here is to eliminate the need for developers to manage secrets in their credentials. So if you think of like a service account in Linux, where you've got an account to access another one, or an IAM role in AWS, for basically your application server to talk to your database server. This is kind of more of what we're actually talking about. They're provided free by Microsoft Entra ID. And they're integrated with many Azure services. So this way we get the Microsoft Entra authentication, and we're getting these Azure role-based access type control things. And it's fairly automated. So basically what's happened is it's going to give us a token, and we can use this token to call services. So kind of like when you've got one system to another system, you don't want a password, because if you've got a password and the password gets compromised, you've got a problem. But if we're leveraging a token, that token's going to have an expiration. So that's really what we're talking about. So let's talk about the types of managed identities we have. We can have a system assigned managed identity. And that's going to be created directly on the service instance. And it's going to be tied to the lifecycle of the service instance. And it's going to be automatically deleted when a resource is deleted. And it's only going to be usable by the Azure resource. By comparison, we can have a user assigned managed identity. And that's going to be created as a standalone Azure resource. And it can be assigned to multiple instances of an Azure service. And it's going to be managed separately from resources that use it. Some basic best practices with regards to identity design. Use system assigned managed identities for single resource workloads. And use user assigned managed identities for shared identity across multiple resources, especially in a frequently recycled environment. We're constantly changing things. And we want to integrate these with the Azure Key Vault. And the point of that is to securely handle service passwords, database type strings, connection strings, license strings, any kind of secrets that we want. So let's talk about storage of keys. So when we have encryption keys, we've got to store them somewhere. I mean, you don't want to put them on your desktop as a sticky note, okay? So where do you do it? Do you put it in a hardware device and store it in a safe? And that safe is inside of a room that's protected by security, and that building has armed security at the edges, and fences and dogs and snipers on the roof. I don't know. You could do that if you needed to for your key vault. And some environments are so secure that they need that. Other environments, we can use the Azure Key Vault, and it's basically a service for us that handles our secrets, our encryption keys, our certificates, and we could pop it into this Key Vault, which is a service by Azure, and it protects our information in a secure environment. So when it comes to this, there's things to know. There's various service tiers. So when you're dealing with Key Vault, you can get a standard tier, which is basically going to encrypt your data with a software key. Okay. We might want more than that. We might want a hardware security model protected key, and that's going to be the premium tier. We can set up access policies, for example, that's going to be tailored to the applications and the individuals that need them. And we also want to basically, and we can actually separate sensitive information. So we may have some information that needs to be separated from configurations and some codes. And why are we going to do this? We're going to do this to prevent the risk of accidental leaks. Key Vault's going to give us a centralized place to do it instead of having to set up this environment with a safe and a security in the room and security around the building. And hopefully Azure provides significant security here, and it's going to give you some logging. The key here is it's going to secure your information and your secrets without you writing extra code. You're going to own and manage your keys in this secure vault, if you will. You can use you can use external keys if you want, keeping your key management central to the app. You can manage your credentials here. The point is, it's a place to keep your secure information. You can also, and might think about using separate key vaults. So you may have different vaults for different levels of security things. So if you put everything in the same vault and somebody breaks into the vault, you got a problem. That's no different if you had a bunch of Bitcoin on hardware wallets and you put it all in one bank, they break into the bank, you're done. But if you put it in one in Greece, another one in London, another one in Argentina, another one in Peru, you've got another one in Dubai, another one in Sydney. Now, even if somebody breaks into one of them, they don't have access to everything. And we can do that here the same way. And that might be something we might want to do. So there's that. And of course, we're going to want to secure access to who can actually get to the key vault. So principle of least privileges, maybe we firewall it off so that only a user on this specific subnet that's allowed to do it can actually access the system. These are what we're really talking about. So let's talk briefly about what is data monitoring. So Azure's got a data monitoring tool. It's called Azure Monitor. And it's a monitoring platform that enables you to kind of view, analyze, and work with the data gathered from your resources. So this platform is going to give you lots of features. So first, we can look at Azure Logs. We can collect and organize data from lots of resources that we monitor. And when we can configure what data we're going to gather and how that data is going to be organized, we can use the stored data inside of our collected data to monitor the performance of our environment. We can look at complex log analysis to try to figure out, things that are going on. Regarding that, we also have Azure Monitor Metrics, and this is going to capture, numerical data, so something with a number attached to it from various things that we're actually monitoring. We're going to get a time-based database effectively. Basically, a metric will be collected at a specific interval, and we can see what's going on by looking at the logs, which have time. We can also get other sources of Monitor data, so we can look for additional data sources that we can collect with Azure Monitor. And this data can be sent to other locations to support certain scenarios, such as tracking and reporting. So, some more things to know. Basically, we can collect data and analyze it from a common set of tools. It's going to give us the ability to look at our logs and our metrics. We can enable a complex analysis through log queries. These metrics can support near real-time scenarios like priority alerts and critical issue responses. We can monitor various data tiers. The highest tiers are going to be for you are going to be the application itself, but we can use lower tiers for components that are part of the Azure platforms. We've got various data locations. We can find out where information about the data, who's accessing the data, where they're accessing the data from. And let's talk about the types of data we might consider. We can look at the application data. We can look at data from the operating systems. We can look at data related to our subscriptions. Those types of things are really what we're talking about. Let's briefly talk about Azure Monitor Logs, which is called Log Analytics. And we can use Azure Monitor Logs to store data in this log workspace. And this is going to be a workspace that's going to give us a boundary or a geographic boundary where our data is going to be stored. And you can think of workspaces as containers where you're going to collect and aggregate your data. Things to really think about, which could potentially pop up on exams, as painful as this is we've got the ability to basically isolate our user access. So we can basically isolate data by granting different users access rights based upon Microsoft's recommended design strategies. We can organize our data too. So the data in this workspace is going to be organized into tables, and each is going to store different kinds of data with the unique properties based upon whatever resources are generating the data. We can configure settings like a pricing tier, a retention policy, and the amount of data that we want to collect. Maybe we cap that data somewhere. And basically, we always want to use role-based access control, and we can use role-based access control to grant users and groups only the necessary access. Now, for organizations that are going to collect a lot of data, meaning over 500 gigabytes a day, we may want to create dedicated clusters for greater control and better data ingestion. Some more things to consider regarding global data storage is if your organization is global, you're always going to have to think about data sovereignty. Some legislation require that you keep your data in a certain country. That's kind of data sovereignty. So we always have to think about our compliance needs. We also may want to think about how we're actually accessing things with regards to transfer charges between regions. So we may want to put our workspace in the same region as our Azure resources. And that way we don't have to pay to transfer data across the cloud. We may want to isolate each department. And by doing so, each department or business group will have access to their systems without interference from others. So there's lots of ways we can structure this based upon our business needs. And we deploy these, log analytics or monitor log workspaces, two different names for the same thing. Where do we want to deploy it? Do we want to collect all the logs in a centralized workspace, which gets administered by a single team? That's got some advantages. That's going to be easy management, gives us the ability to search across all resources, gives us a cross correlation of logs. Okay, something's going on the routers, something's going on the firewall, something's going on in the system. Maybe we've been hacked. That kind of correlation is great. But now, with that comes the disadvantage. We've got a lot of growth of the workspace. We have a heavy administrative overhead. By comparison, we can do decentralized, where each team has its own workspace and they secure and manage the log data. Well, this has advantages too. It's going to provide very consistent access control. Only certain people will be able to use it. The disadvantage is going to be very hard to cross-correlate your logs from various systems and various parts. And architecture is really just a trade of, evaluate all trade-offs and which one is best for me. We can also deploy these in a hybrid environment where we can make a combination of centralized and decentralized logs. And that gives us flexibility. But by doing that, Now, it gets fairly complex, expensive, and hard to maintain. And maybe by creating this hybrid environment between centralized and decentralized, we have potential gaps in our lob coverage. So nothing's free. Nothing comes easy. You have to think about all these pieces. Now, when it comes to access mode, we've got a workspace context and a resource-based context. The workspace context gives you the users the ability to review all logs in the workplace for which they have permission. And the scope of this is queries are being able to scope to all data in the table in the workspace. By comparison with resource-based, users can access the workspace for a specific region or a resource group or a subscription. And the scope of this is going to be scoped to the data only associated with that resource. Now we'll briefly talk about workbooks and insights. Azure Workbooks and Insights. So Azure Workbooks are going to provide a flexible canvas for data analysis, and it's going to be able to help you create a rich visual report inside of the Azure portal of what's actually going on. They're helpful for combining data from various sources, disparate sources, and they let you get some insights and analyze what's really going on. So some things you can think about is multiple data sources. And we can also transform that data. So we can take the data, we can transform it, how we ingest it, get some insights on our availability, our performance, and the overall health of our system. So we can use these insights to get these interactive reports. We can analyze the performance logs. For example, we may find that our CPUs are too high on various applications and we need to move them to bigger virtual machines or add more capacity. We may find some low memory instances. If it's a Windows server and we hit the swap file and you've got excessive paging, you need DRAM and go fix that, for example. So we can look at that as well. And we can look at utilization of memory. So some compatible data sources are going to be logs, metrics, the Azure Resource Graph, alerts, workload health, Azure Resource Health, Azure Data Explorer. And the point here is we're going to get customized monitoring experience of particular applications or particular services, and we're getting logs and metrics. We can set up customized monitoring to provide a tailored experience to a specific application or a service. We can really collect logs, analyze logs, and that's really what we're trying to do, obtain better information. And I'll give you some examples that you might use. We might want to use from an application insight perspective. We may want to monitor a live web application. We may want to look at various containers, call it container insights, and check the performance of a container workload. Network insights, we want to get some health of the network, what's going through the network, that type of thing. Virtual machine insights, we can monitor the health of our virtual machines. We can get some insights on our Azure cache for Reddit and review performance, failures, capacity, that type of thing. We can look if we were going to use this Azure Cosmos database, which is not a great option for a NoSQL database in a multi-cloud environment, but great on a single cloud, which 2% of enterprise customers use. The other 98% of the customers don't use these proprietary tools as a rule. Use something like MongoDB or Apache Cassandra. And we can even get insights into Azure storage. So lots of things we can do here. Now we're briefly going to look into Azure Data Explorer. And that's going to be a platform for big data that's going to aid and analyze and looking at large volumes of data in real time. And it's going to be equipped with features for configuring end-to-end solutions, data ingestion, management, what have you. Things to think about is it tends to be fast. It tends to be scalable. It enables you to connect to multiple data streams. So we finished that section, and that's probably going to be the most painful section of this entire training program. And the next thing we're going to talk about is designing business continuity solutions as it pertains to Azure certification training, which may be very different than we might want to do in the real world in today's world of multi-cloud environments. So I'm going to see if anybody had any quick questions that we have. And if not, we will go back to the content. Chris, see if there's any questions that popped in. If you've got some questions, let me know. I'm going to wait a couple seconds to see if questions come in. And I'll do the best I can. That's not area of monitoring is not my area of expertise, but I'll do the best that I can for you. In the meantime, there's lab demos if you want to get hands-on. Chris and my team just will pop the link for that in the chat box for you. Got some free career questions that we're going to do tonight. Answer anything, ask anything you want. We'll do anything we can to help you. Got lots of decades of experience in helping people land jobs, get promoted in tech, and that's going to be completely free on Zoom. Chris will pop the link to register for that. And tomorrow we're going to talk about how to get your first architect job. Well, Chris, do we have any questions here? So if you got some questions, ask. Otherwise, I will start talking about designing for business continuity solutions. And while we're at it, if there's no questions, that's fine. It's not the most exciting topic to talk about, and a lot of that is some memorization, so to speak. So give me a hashtag AZ305 so I know you're still awake after that very painful conversation, and we can get into things that are going to be more interesting though. And okay, I guess I will get back to the content, and I am totally fine with that. So we're going to talk about disaster business continuity planning. And the first thing we need to understand is what's called maximum tolerable downtime. And that's how long a business can be down before any irreparable damage is there. So with that, comes how available do our systems need to be, how much downtime we can tolerate, RTO and RPO. So we're going to talk about that next. So if a business has a maximum tolerable downtime of 1 hour, and after 1 hour, the damage to that business is irreparable, then we need to get that business up and operational, which is called the recovery time objective, in less than that 1 hour, because we don't want long-term business damage. So that's the RTO. What are the consequences of not getting your business back up before the maximum tolerable downtime is reached? Well, the company can go out of business. The customers could lose trust in that business, so to speak. So we need to figure it out from the business perspective. And we're going to have component level RTO and total system level RTO. For example, maybe we can tolerate the database being down for 20 minutes, but the rest of the systems can be down for an hour. That means that database has to be up within 20 minutes and the rest of the systems within an hour. And we really have to look at the cost of downtime. Some businesses have very limited cost of downtime, and other businesses have high cost of downtime. Let's see. So, AWS has about $900 million of every minute of revenue loss. So what does that mean? It means if the business is down 60 minutes, that's about $60 million. That's a lot. So for that business, it might make sense to spend more money on high availability. Likewise, we may have a local shoe store that does, $100 an hour of business, or $200 an hour of business, or $300 an hour of business. And if they're down for 2 hours, well, maybe that's $600 maximum loss. That's not going to justify that business to put in a $50,000 or $100,000 disaster recovery plan. So we have to really think of the cost of downtime. Now, recovery point objective is the amount of data loss that the business can tolerate before it has problems. And we have to plan for that too. So if we've got a 24-hour RPO, recovery point objective, it means we need to back up once every 24 hours. And that way it'll always be less. Because if we back up at 9 a.m. and the systems were to fail at 9 p.m., and before when we're going to have 12 hours of lost data, so to speak, before they come back up. So it's going to be upwards of 24 hours in that use case. Some businesses may tolerate 15 minutes. Some may tolerate an hour. But if we've got an RPO or recovery plan objective of of a total of say 30 minutes, we're going to have to back up maybe every 15 minutes or something like that to make sure our data is fresh, or at least more than every 30 minutes. So at least think about that. And when we do backups, we definitely need to constantly test our backups and make sure they work. So how do we define our recovery time objective? That's based on the business's maximum tolerable downtime. It must be less than that. We have to look at the cost of downtime. What does that cost? And then we need to think about, how do we plan around it? Is it fine to just use something like an always-on availability group or an always-on failover cluster? Or do we need to use more than one cloud? And high availability or disaster recovery are two very different things. So let's talk about the difference. Availability is, are your systems there when you need them? The kind of businesses I work with, mission critical healthcare systems, global banks, they can tolerate about 5 minutes and 15 seconds of downtime per year. That's called 99.999% availability. Some businesses can tolerate 52 minutes of downtime per year. That's 99.99% availability. But that's normal stuff. And what are we talking about here? Cloud provider goes down, it's expected. Okay, you're on your other cloud provider, and it comes back up. That's part of your normal high availability design. You can tolerate it. These are resilient systems. No single points of failure. Stuff can break, and you're fine. Disaster recovery is something a bit different. That's when an earthquake happens along with flooding, and it takes out all the power within 30 miles. And your backup generators, well, actually, they're typically running on natural gas, so you don't have a problem. But if they were running on diesel and you only had 12 hours of diesel fuel and you couldn't get new diesel fuel shipped in because there was a problem on the roads because you had a a pretty bad disaster, and you got to go build up somewhere else, that's disaster recovery. So they're not the same. And they take very different things here. So, obviously this is going to be related to your architecture. And it's not just going to be your cloud, it's going to be your networking, and it's going to be your security, and it's going to be your change control processes. There's so much that goes into building a high availability. It's related to the code reviews of the people that are deploying software, the quality assurance, all of this. But it's a certification exam. We can't really get into the full truth of this. We've got to get you to pass the exams. And if we give you too much information here, the exams are going to be hard because you're going to know too much and know that what's in the exam isn't going to be exactly correct in reality. So we've got to walk that fine line, which is what we're trying to do for you. Now, when we're dealing with infrastructure as a service, we have full control over our virtual machines, our operating systems. We've got great flexibility, and we've got a lot of control over the situation. But we have to plan very, very, very heavily on what we can do. By comparison, if we're using one of these, platform as a service type things, where we just upload our code and it sort of works, well, we have very limited configuration options, and we have much less customization. We're going to have to trust the cloud provider stuff that it's going to work. Now when we're dealing with SQL Server, we've got this concept of these always on failover clusters, and that's going to protect your entire SQL Server instance or system or machine, and that's going to typically rely on some underlying cluster mechanism. So maybe Pacemaker for Linux or WSFC for Windows. It's going to need some shared storage so that if one system goes down, the other system can access it. We're going to need load balancers, typically speaking, internally, because most databases are internal. And that way, we've got some functionality. And what's going to happen with the database server, the failover, is going to involve shutting off the one SQL server and starting a new one. So when it fails over, you're getting a very brief disconnect between the two. We can also create this concept of an always-on availability group, and that's going to protect the database, and it's going to support synchronous and asynchronous data movement. We can have multiple replicas, upwards of 9 in the Enterprise Edition version, and basically it's going to use a listener. And for connection abstraction, it's going to require like an internal load balancer. And it's going to allow read-only access to secondary replicas for offloading tests and backups. So when we're talking more about these always-on failover cluster instances, it's going to be a high availability solution for SQL Server. Again, at that instance level or that virtual machine level. Make sure we got this. And when we implement this always-on failover cluster, it's going to be very similar to what we did on-premise, but it's going to use Azure-specific storage solutions and Azure-specific connections, as opposed to whatever storage we feel like in our data center. By comparison, these always-on availability groups are more of a high availability disaster recovery solution for SQL Server, but that's going to make sure your databases remain accessible even during outage. It's essentially the same feature with the always-on availability group, but it's going to be deployed in, say, the Azure cloud environment. You can also do something called log shipping, and that's going to provide a simple method to basically back up, copy, and restore. And this is going to be great for disaster recovery because it's going to provide database level protection, but it's going to lack any kind of native abstraction. So it'll require manually handling of SQL Server agent jobs, login, and link services. So let's talk about some high availability and disaster recovery options for platform as a service offerings. So when we're dealing with platform as a service, they typically provide what they consider to be built-in high availability and disaster recovery options. Well, here's the problem. They do this, so it's going to let you use Azure's capabilities, and you're not going to have to think of managing the underlying infrastructure. But here's what it's going to do. It's going to back up your systems to other parts of Azure. So if Azure goes down, you've got nothing. So just keep this in the back of your mind. But it's going to cover SQL-based options, Azure Database for MySQL, Azure Database for Postgres. And it's going to provide what's called active geo-replication. And what it's going to do is it's going to create up to 4 readable secondary databases in the same or different region. And that way, if you got a problem with your main database, you can fail over to your other one. So that's realistically what we're talking about here. We can also do something called an auto failover group. And that auto failover group is going to support automatic failover for a group of databases to a secondary server in the same region or different region. And as long as your cloud's up, you're great. But if your cloud's down, you've got a problem. That's going to give you a nice transparent failover for databases inside of a failover group. And it can be used for, say, high availability and disaster recovery. Some SQL Server-based options. So we've got this Azure SQL Database Managed Instance, and that has auto failover groups. And that's going to be very similar to the Azure SQL Database, where it supports automatic failover for groups of databases. And it's going to give you some high availability and disaster recovery for databases that are in the failover group. Now, when we're dealing with Azure Database for MySQL, it's high availability, meaning it guarantees 99.99% availability. That's a pretty big guarantee, given that a lot of the cloud providers have not provided 99.99% availability for their entire cloud. So take that with a grain of salt. If you fail, they'll give you some money back, and that's what that SLA is like. So the failover mechanism here is it's going to provide an automatic failover in case of a node level problem, like a virtual machine problem or whatever the system problem is, like a hardware failure. And it does provide some very nice synchronous data replication storage upon commit. So as soon as something's written, it's going to replicate everywhere. And basically, a new node is going to be created and data storage will be attached during the node level interruption. So if something happens to one system, it creates a new one. And that's going to require an application retry logic. So if you try to send your message to one database and it doesn't work, send it to the other. That's that application retry logic we're talking about. Let's talk a little bit about read replicas. So generally speaking, a read replica is a read-only copy of the database, and we use it to database scale, like we talked about in the first week, pointing that read traffic to the read replica. And they're usually used for offloading work from the primary database, but it's providing a database in a different region, and we can potentially promote that to a primary database. So we can also talk about Azure Database for Postgres. And that's going to be another database. Postgres is often used as a data warehouse, even though it's technically a relational database. And that's got its own way to work as well, just like the Azure database for MySQL in terms of high availability. It's going to provide some automatic failover with synchronous data replications. And again, we have the opportunity for read replicas for either reporting or read intensive operations. We can enhance availability by locating it to a different region. And applications using Postgres, again, if we're going to use this retry logic, have to, of high availability, have to have a retry logic, meaning go to server one's dead, go to server two. So make sure there's some kind of application level retry logic and some form of error handling in the applications itself. And we should design for failures. So cloud applications should be assuming that things go wrong. And how do you handle these failures gracefully? I mean, we always have to design things that go wrong, but at cloud especially, because there's more things to go wrong than in the data center, because these are much more complicated data centers. I mean, they're the same, but they're big and they're hyperscale and they've got greater levels of control plane and things going on. So we have to plan around it. Let's talk about designing for backup and recovery. So we need to make sure we've got resilience. So anything that matters, we have to think 2 is 1 is none. So 1 of anything is no good. 1 power company coming in, not good enough for a real data center. 1 router that's only got 1 power plug, not good, because the circuit goes, the power supply goes, you go down. 1 server, no, we need 2 servers with a load balance and a load balance between them. So always think about that. So we need to make sure our apps can stay healthy. And we need a good backup and restoration process to ensure that when systems break, and they will break, or when data gets corrupted, and it will get corrupted, we can store that data properly. So when it comes to backup, the first thing we need to do is think about the business requirements. How fresh of the data do we actually need? So we have to look at the business needs. You have to assess the criticality of our various workloads, determine the impact of downtime, and the impact of data loss on the business. After that, we can start building a resiliency plan. And that's where we plan for what level of redundancy we need, what type of failover mechanism we're going to place, and then we can develop a backup and restore policy. Now, when we're dealing with backup and restore, we have to think about their workloads and usage. And each workload is really going to be separated by a different business logic and potentially different data storage needs. Different workloads will have different requirements for availability, scalability, consistency. And we also have to think about our usage patterns. So we're going to have critical periods and non-critical periods. And during critical periods, we may need more resources. And during less critical periods, we can potentially save on cost by reducing resources. Maybe we do our backups during non-critical periods so we don't further tax the systems. So a couple of things to think about. Mean time to recovery is going to be the average time to restore a component failure. Think about that. Average time. And the next is basically mean time between failures or mean time between outages. So in a data center, they typically don't use the generic hard drive that you're going to buy at your local computer store. They're going to buy an enterprise hard drive that's going to have, say, an average of 2 million hours mean time between failures. So they're designed for higher availability. They may perform at 2% less speed, but they're designed to write over it, never wear out or almost never wear out. By comparison, consumer grade stuff may not be designed to resign for extra features, not that level of availability. So we have to think about what level that we can take, how long of a failure we can tolerate, how much of an outage we can tolerate, and what we need to do to work around it. In an emergency call system like 911 in the US or 9999 in the UK, if you've got to pick up the phone because you need a police, fire, or an ambulance and they don't come, people die. They can't tolerate a lot of failures and they need to work around it. By comparison, Fred's shoe store might be able to tolerate it a lot more. So we're going back, and I've talked about the recovery time objective, which is less than the maximum amount of downtime. And the recovery point objective is the maximum amount of how much data we can use before we have irreparable damage to the business. So we've got to get it back before that. But we also have to talk about recovery level objective. And what is that? Maybe I can tolerate our business coming back to 50% capacity for an hour or a day. And that will also determine our backup, our recovery, and our high availability plans. And we also have ideally would define so we also would probably look at our workloads, and we should set a target service level agreement for each workload. Maybe a bank's training system can't go down, but it can tolerate other things from going down. So these are kind of some of these things that we should think about, and we always have to plan these around these things. Now, we always have to think about the customer and the provider. If you work for Microsoft, your customer is the people buying your stuff. If you work for a company itself, let's say you work for a bank and you're in the IT department, your customer is the banks and its users. So there's always a customer we're dealing with. And if we're dealing with Azure, we're going to get a service level agreement that's going to give us what they project that we think we need and what we need. Now, if you're dealing for a customer, you're still going to have to define your own SLAs, meaning what your customers will need from you. And we always need to think about what kind of technologies we're going to use to recover. And we're going to have to make sure that our technology backup plans also integrate with our business continuity plan. So, what part of the business needs to come up? When does it need to come up? Where are our users going? Who's speaking to the press? Who's dealing with legal? That kind of stuff is it's just a sample of the small percentage of things we have to deal with the business continuity plan. And our disaster recovery plans are integrated in this. And at the architect level, we've got to focus on all of that, not just this tech piece. Because then it's just tech in a vacuum, which again provides no benefit for anyone. Going back to the high availability with infrastructure as a service, we've got control, lots of it. And we can tune it based upon anything we need. With platform as a service, like the Azure SQL database, where you're not managing servers, you're just putting your data in there, it's got its own high availability solution, and hopefully that's going to meet the needs of your business. So going in, what technology do you choose? You're not going to go serverless because it's cool. You're going to go, what's going to support the needs of the business? What can I tune? What level of control do I have? And that's why we can't have any tolerance for bias or people loving any particular technology. It's got to be based upon the business. So let's briefly talk about some high availability for virtual machines. We can basically create something called an availability set. And the purpose here is to reduce single points of failure inside of our data center. So if a computer goes down or a server goes down, maybe we switch over something else. So it's going to act like what's called an anti-affinity rule. And it's going to ensure that your virtual machines and availability set don't run on the same server. Because if you're not careful and you don't do this, you can have a primary virtual machine and a backup virtual machine on the same server. And if you've got a software crash of your virtual machine, that's fine. But if the server fails, you got a problem because now both virtual machines are on the same server. So we need to think about these things. We have to think about fault domains versus upload domains. So a fault domain is going to be a group of servers inside of the data center that's going to share the same power source and network. So you're typically going to see upwards of 3 fault domains in a data center. Same network, same power source. So we don't want everybody on the same power source, right? Because when that circuit breaker blows or the transformer coming into the building blows and then that generator kicks in, we've got some problems there. So we're going to make sure that these systems are somewhat spread out. We also have the concept of an update domain. And that's going to be a group of virtual machines and underlying hardware that can be rebooted simultaneously. The point here is to ensure some separation during these updates. We have to come up with something called the protection scope, and that's going to guard against the data center environment, hardware failures, network outages, power interruptions. Now, you should never see a power failure in a data center. I've never seen it before in my life, except for AWS said that one of their data centers failed, which caused a global outage due to a power failure. They're the only one I've ever seen in an enterprise-grade environment in my life. Because normally speaking, You've got multiple power companies, different transformers, generators, batteries, backup generators. So I've only seen it with AWS, but anything is possible. And we have to think about that. But even still, that's not going to protect against an in-guest failure. So we've got a virtual machines operating system which crashes. So that's why we use solutions like always on availability groups or Azure on failover clusters to be able to introduce higher availability systems. We also have the concept of Azure Site Recovery. And that's really about protecting against a data center failure inside of the Azure region. See, in most cases, each region is going to have multiple data centers called availability zones, and they're going to have, like, typically speaking, dark fiber underneath the ground or some high performance network connection. And you're not going to want to put all your resources in the same data center. What if the data center catches fire? What if a pipe bursts inside of a data center and it destroys all the system? So think about that. Now, when we look at these zones and the numbers, these numbers are logical, not physical. So, but whatever the case is, it's logical separation. Now, if we put our system in between availability zones, we're going to introduce latency. But round trip latency with dark fiber within 10 miles from each other or so is going to be low, typically less than 1 millisecond. This is not like go from your campus to the cloud and have 10 milliseconds of round trip latency time. Still going to be relatively good performance. So let's talk about platform as a service deployments. There's limited options here so that we can actually do. So we really want to focus on built-in solutions if we're going to use that with minimal configuration, because that's all we got if we're going to do this with platforms. So try to think about that. We've got less options. So if we're going to use a SQL database, applicate geo-replication. And that's going to basically create readable databases in different regions, which are going to give us some disaster recovery with minimal data loss if the other Azure regions don't crash or go bad. We talked about auto failover groups for our databases. That's going to support failover of multiple databases in a group. They'll fail over to a secondary region in an event of a primary region. As long as that other region is up, you're good, meaning it didn't have a network failure, a control plane failure, or a hacking event. Bear with me a second. Okay, so let's talk about designing storage solutions. Chris, how long has it been since I took a break before I get to this content? You'll mess with me. About 20 minutes. Okay, so let's take a few questions. I think I saw 2 pop in. And then from there, we'll go back to the next content. Do I have any recommendations as for practice exams? So the reality is you should actually get one. But which vendors I actually like or don't like in today's points for Azure, I don't actually have a great recommendation here. I don't typically think in terms of the certification materials, but I would do a good Google search. Let me do a quick one right now because I can typically tell you who makes reliable things. So I typically know the vendors that produce something good. Microsoft has some practice assessments directly on their website. WizLabs typically has some good certification type materials as well. Exam Pro might be someone you could also use. I'm familiar with these companies. They're more focused on certifications than we are. We're more focused on taking those people that have taken that kind of training and then training them so they can actually have a job, not just get a certification. So that's why, so there's that. Of course, we can go to the next one. What's the difference between an availability zone and an availability set? That is a great question. So, an availability zone is basically a separate data center inside of an Azure region. If one zone fails, the other one remains okay. By comparison, an availability set is going to be a group of virtual machines inside of a single data center that ensures virtual machines are distributed across multiple fault domains. So that's really there. So blue-green deployment will assist in application and disaster recovery. So yes, under certain circumstances. So a blue-green deployment is typically where you put a percentage of your environment in one and you've got something new somewhere to deploy an application. And regarding that, that's typically good. So what we could do in with regards to disaster recovery is we could do, realistically speaking, one of four different options. And I'll explain the options, Mohammed, and then that'll hopefully make sense. Option one, which is typically called backup, which is basically you back up all your data, say once per day, or whatever your RPO is, and you stick it into another cloud's environment. You make images of your virtual machines, or you have a Terraform infrastructure as code script, and you launch what you need based upon the data you've stored in the cloud. That's option one. Backup option two, I like to call backup plus. And it's basically that same thing that we just described, where you've got copies of all your data, basically virtual machine images and maybe a Terraform script. But in this particular case, we're synchronizing our database between, say, the AWS cloud and, say, the Google cloud. Now, the next option we have, which is sort of almost but not really like a blue-green deployment, we could basically have our primary data center up and running, our primary cloud. And then send our backup cloud, we have a micro version of what we actually have. So if we've got 50 web servers in our primary environment, in the backup, we have maybe one or two web servers. If we've got 1,000 application servers in our data center, maybe we've got 10 application servers in the backup cloud, and replicate that for our entire data center. And now, if what do you call it? Our primary data center were to go down, and say it's a web application, DNS will detect the outage. It will send all the data to the disaster recovery environment, and the disaster recovery environment will be overwhelmed. And that disaster recovery environment will be overwhelmed, and auto scaling will kick in, and then everything is good. So there's that. And then the last form of disaster recovery is we have an identical version in the one cloud and the other cloud. Now, granted, each of these take a different period of time. That backup and backup plus may take a substantial period of time to get back. That environment where we've got that warm standby and auto scaling is going to kick in, that's going to take about 45 minutes to come up to full capacity. Obviously, running a hot data center, we are there. Bear with me. I have to just grab this real quick. Okay. So there's that. So, Mohammed, it was a great question, and I hope I answered it. Thinking back, actually, I know a guy that actually has some very good practice tests. His name is Haman Sharma, and he owns Review and Prep. I didn't think about it, because my focus is typically not certifications. It's more getting people hired and getting them promoted and increasing their earnings. But yeah, that's a good one that I would definitely recommend. And I've seen Haman's work in the past and his site, and there's lots of good information there. Chris from my team will share the link. Okay. Well, let's go back to the content. So let's talk about designing for storage. So we talked about storage in the beginning, and what is storage? It's where we're going to store our stuff. And typically speaking, when it comes to data and where it's being stored, we have what I would call volatile, and we have what's called non-volatile. Volatile storage is your DRAM. When you shut off that computer, reboot it, it all goes away. Non-volatile storage are things like a hard drive, for example. And when we design for storage, these are lots of things we need to think about. We need to think about the who needs to be in control, the type of workloads, the architecture of what we're dealing with, the type of data. So let's talk first about control. We have to determine the level of control needed over our installed software and applications. So what do we need for our virtual machines? Typically speaking, some form of block storage. But we also have to think about the workload. So when we're dealing with block storage, even the cloud providers, when I call it exciting on a certification test, it's really, really slow. Meaning you may get a server in your data center that's got 8 NVMe drives on a RAID card. It gives you 8 million IPS. That's good storage. But the fastest block storage we can get in Azure is 160,000 IOPS, which is kind of nothing in the grand scheme of things. So we may have a high performance workload that's going to need something better. AWS has this concept of luster. And for example, if we needed NFS with AWS, there's a third party provider called NetApp that will basically make luster kind of feel like NFS. Or there's another thing they can use to make luster feel like block storage to make it feel kind of fast. So you don't have to deal with the slowness and the bad performance of block storage in the cloud. Azure has things like Azure Batch for high compute storage. So there's that. So we also have to think about what kind of architecture we're dealing with. Are we dealing with virtual machines? Are we dealing with microservices? Are we dealing with serverless? And each one of these is going to take different options that we may want to use. For example, we might be using a Kubernetes environment for microservices and orchestration, and maybe using Azure Functions for quick little mini event-driven thing. We also need to think about what our data looks like. So let's talk about structured data. Structured data is typically going to be best stored in a database. And it's typically stored in a relational format that's going to have a shared schema. And maybe it's going to have data that's combined in tables and rows and columns and keys. So think about relational databases, maybe medical records, phone books, financial transactions. At the same time, we may have some semi-structured data. And that's going to be less organized. And maybe it's in an HTML form or JSON form or XML form. And we might maybe want to store where you're at in a Netflix video, like you're in this scene right now. I'm watching this new TV show called The Old Man. I think it's on Hulu about an ex-spy where the people are coming after him. I'm finding it interesting, but I never have more than 10 minutes at a time. So I pause it and I want to go back to it. That's typically going to be stored in a NoSQL type database. And then there's this unstructured data, which is going to be completely unorganized data. So maybe it's my 150,000 photos of my cat, Cindy. I'm exaggerating the concept a little bit, not that much. I've got way too many photos of my cat. Or I've got Word documents or PowerPoint slides or PDFs or things like that. That's unstructured data. So let's think about what we would use and when we would use it. And we talked about this in the first week under the fundamentals section, but let's talk about it more under our official certification training. For large amounts of unstructured data that is not going to be mounted by a virtual machine, images, multimedia, we're going to put it in object storage, otherwise known as Azure Blob Storage. They made up the name Blob, binary large object. I think of it as object storage. That makes sense to me. Now, what about file storage? So let's say I've got 50 servers that need to access the same information at the same time. Well, now we need file storage. So, we used to set up an NFS server or a Windows file server, and that's basically what we're dealing with Azure Files. It can provide us a Windows-based file share using the server message block protocol, or a network file system share using the NFS protocol, or we can deal with Azure Files to say maybe a REST API as well. Now let's talk about the disks. So we can also talk about block storage, otherwise known as Azure Managed Disks. So your virtual machine is going to need some type of storage that actually persists after you delete the virtual machine. And that's going to be your Azure Managed Disk. And they are block storage, meaning they're accessed over a network. And we talked about those storage area networks in the first week. So if you haven't seen it, go to the first week of fundamentals, and that we would be using. But what about if we're going to go from our application to our database, or we've got a microservices based environment and we've got messages that need to be passed through? Where do we store that? Well, we put it in a storage queue. So that's the point of Azure Queue Storage. So why are we doing this? We've got 1,000 little transactions that we need to hit the database. We pop it in the queue, and when the database is ready. So we basically are creating a backlog of work so our servers can handle them asynchronously when ready. So let's talk about how we would design these. So first thing we need to do is understand we're going to create a storage account. And the point here is to group all of our Azure storage services under a unique namespace worldwide. And the benefits here are going to provide durability of our data, meaning that even if we delete it, even if it's down right now, for example, it may be available afterwards. We need some high availability, meaning if we need to access the data, we can. We want to be able to secure our data, and keeping it in our storage account with IAM things can help us. And we need the scalability. So the whole plan of the cloud is it scales. We're going to pay more for storing our data in the cloud by 3 to 5 times the amount in the data center. But in the data center, we have to worry about running out of capacity. In the cloud, we don't have to think about it. So there is that. And we need to think about the location of our data. Do we have to be in the same country with regards to data sovereignty? Can it be spread across the world? That type of thing. Who owns the data? And organizations, realistically speaking, enterprise will have many, many, many storage accounts for different things. And then we need to check the storage type. So let's talk about premium file shares. That's with Azure Files. And, if we need better file share services, we're going to use premium file shares. Again, for NFS or SMB for Windows, NFS for Linux. We can also do premium page blobs. And that's going to be the best storage performance we can get regarding our page blobs. And that's going to be based for maybe some index-based sparse data structures, data disks for virtual machines, databases, that kind of thing. And where are we going to store it when we consider these human design considerations? So in a perfect world, we put our data storage closest where it's most frequently used, because it's going to give us the best performance. So we have to also think about if the data has to be in a specific country or region, and there's lots of legislation around it. And we also want to think about our data storage costs. We have to think what our storage costs will be. If we make it geographically redundant, it's going to cost us far more than if it's locally redundant. So we need to think about what storage needs to be hot tier versus something else. And we need to track expenses by departments and see who's spending what. And does it make business sense? You may have a department that's spending a fortune on storage, but your business isn't getting anything out of it. So you constantly need to tune, optimize. And then we want to think about where it's going to be replicated. I may have talked about that before. Geographic redundancy is going to give us the best availability, because hopefully if the US regions are down, the European regions will. Not guaranteed, but hopefully. That's why multi-cloud tends to be a better option. But, we need to think about that. But then it's going to get more expensive. And pulling it from a farther distance is going to be there. So there's always things to think about. And we also have to think about the administrative overhead. It's not just what it costs. How much is going to go in to maintain these storage things? Multiple storage accounts improve security, but it adds more complexity. Trade-offs, always trade-offs. And then we can talk about data sensitivity. So some data is going to be more sensitive. Proprietary data, trade secret data, and maybe that data should be stored in a separate storage account that very few have access to. We also think about data isolation. We may want to use multiple accounts, so maybe statutory data or regulatory data, compliance data can adhere to whatever necessary policies that we have to adhere to. So, a little more about designing for data redundancy. The purpose of all of this is to deal with unknown and unknowable as well as planned events. An unknown event is when you're going to get an earthquake in Florida. That's kind of unknowable. We don't know. Now, we do know and can plan that we're going to get hurricanes in Florida, but we don't know when they're coming. So in Florida, we build our buildings resistant to hurricanes because we know they're going to happen. So that's unplanned. But unknowable is something bigger. When is the war? If a war would occur and bombs were dropped on an area, what would actually there? So some of these things are just unknowable. Unplanned events can include those kind of natural disasters. They can include war. They could deal with these internet service providers who actually provide internet transit and private lines to the cloud providers going down too. So we need to figure out what our availability and our durability targets are for every part of our environment, plan around them, including storage. So I talked a little bit about these before. With regards to primary data replication, the data is going to be initially replicated in the primary region. And that means locally redundant storage. So it's going to be the lowest cost level of redundancy because here we've got a server rack that goes bad. It's going to be stored fairly locally in the same place in the data center. And, I do some of that in my home. I've got all my drives sitting in all my systems, and they all back up to a NAS device in the same building. So there's that. I also synchronize my NAS device with another property that I own that's 1,000 miles away. And that way, if my main hard drives go down and my clouds were to go down, my locally storage is now replicated geographically far away. So there's that. But the zone redundant storage is going to be less than that. Basically, it's going to have whatever you have in your data center is going to be sent to another data center in the same geographic region, a different availability zone. So if the data center were to go down, another data center in the region in the region will take it over. But remember, these things are close to each other. So if we had a pretty bad catastrophe in that area, well, then poof, guess what? They're all down. So there actually is that. I kind of wonder I hope that makes sense to you. So there's that. Now, secondary region replication is a little better. That's kind of the environment that I described by me keeping a NAS device in my house and a NAS device and 1,000 miles away. So with regards to this, that's called secondary region replication. And basically, it copies your information to another region. So if you've got a regional disaster, like a hurricane in Florida, and all your availability zones are in Florida, you're good to go. If the region goes down or the cloud goes down, you've got nothing. But this is still a much better option. Better option, go to another cloud at that point. And that way, if you've got a major outage in your cloud, your other clouds kick in. And it doesn't cost more to put 50% of your stuff in AWS and 50% in Azure than it does to stick 100% in AWS or 100% in Azure. Just a little different design. For the most part, the costs are basically the same. So there's that. And then we can also do a different form of secondary region replication. And that's, we can do geo-redundant storage, which replicates in the locally redundant environment. And then we can also replicate via various regions at the same time. So we can do lots of these things that we need to do. Now let's talk about designing for Azure Blob. So that's our object storage. Remember, we have various blob tiers. So we need to figure out storage performance, storage availability, latency, and cost requirements. We also need to think about whether our data needs to be immutable or not. And I'll explain what I mean by that. I don't need immutable data for my cat Cindy's photos. I don't. So I've got data. If Alonzo from my team were to hack into my system and he were to take my cat's photos and he would have put little funny whiskers on my cat Cindy and say, Mike, I did it, it's no big deal. By comparison, if I've got a financial transaction for a bank that just purchased $100 million of Apple stock, and then later, and they need to keep that for the government because they can't change it, because later if the SEC would come in and investigate that bank and they saw that data had changed, billions of dollars of fines would occur, or people would go to jail, or a combination of both, which is something people don't want. So if you're dealing with medical records for your patient, they need to be immutable or unchangeable. If you're dealing with banking records, they need to be immutable. So when it comes to storage, we need to determine that, because we can set up various ways to make our data immutable versus making it changeable based upon business needs. So regarding Azure, we've got the first type of blob tier we have is the hot access tier. And realistically speaking, by itself, that's 99.9% availability. Not so good at all. But if we combine that with geo-redundant storage, that means we can access our data 99.99% of the time, which is about 52 hours of downtime per year. Not too bad. The latency to that is somewhat quick. It's milliseconds. So it's not fast, but it's not horribly slow. And we also have to understand that if we're accessing that data over a wide area network, say from our campus to the cloud, we may have milliseconds of latency for the object storage and milliseconds of latency for the actual wide area network itself. So we have to think about that. But where we would use this? So we're going to frequently access our data, store our data, and access it. This is our best option. So it's going to give us very low access costs by comparison, but we're going to pay a lot to store our data. So actively processed data, definitely we're going to use this hot access tier. By comparison, we have the concept of a cool access tier, and that's a whole lot like that AWS S3 infrequent access. And basically what's going on here is we've got some pretty terrible availability, 99% availability. So that means you won't be able to access it more than, I think it's about a day a year. So it's pretty big for 99% availability, or more than a day a year. If we use geo-redundant storage, it goes up to 99.999%, which is going to be many hours per year that you can access your data. Latency is milliseconds, and you have to store your data in this cool tier for at least 30 years. So data that we don't need to use a lot, but we still need to be access it and get it when we need it. So again, like that S3 infrequent access, here's the thing. When we use this cool access tier, we're not paying a lot to store our data. And now we got to pay to retrieve our data too. So we might use it for short-term backup, a disaster recovery data set, some old media content. And then we have this concept of the cold access tier. We talked about hot, we talked about cold, now there's cold. Now cold access tier, again, it's got some pretty horrible availability, 99%. If we use that local geo-redundant storage, we get it up to 99.9% availability, which means many hours of downtime per year. Latency is still milliseconds, and we have to store our data here for at least 90 days. So infrequently accessed data that we're going to retain for long periods of time, very similar to cool, but it's optimized storage, but optimized for longer term storage. So you pay less to store it, but more to retrieve it. And then, of course, we have the archive access tier. And that's basically like AWS Glacier. And here what we have is, again, horrible availability, 99%. It goes up to 99.9% with geo-redundant storage. The latency to get our information is hours, but we're going to store it very cheaply, and we're going to pay high access costs. So we might use it for information we don't need very quickly. It could be a secondary backup of our information. It could be raw data. We may actually store like our healthcare logs and something like this. So because we're required to store them, I think, for 7 years. So that type of environment. We also have the concept of Azure Blob Immutable Storage. And that's for what we're talking about with regards to where it can't change. Now, healthcare people may keep everything they had in an environment like we just talked about because it's cheap. But if they want to guarantee that it's not been modified, and for compliance purposes, they probably should. Although in many cases, you find organizations that just keep something in that glacier for long term. But when we make it immutable, it's great for highly regulated industries like healthcare or banking, what have you. We can set a time-based retention policy, and where it can be for that. We can put a legal hold on it. So if data is got a legal hold on it that might be cleared, potentially is information that lawyers may need to be accessing for a trial, for example, we can pop it in this environment. It's stored, and it can't be changed until the case might be over, that kind of thing. So there's lots of use cases for this. So when we're dealing with Azure Blob, we have to, again, think about that availability. And as you saw, not all these have very good levels of availability. We have to think about the latency. The archive tier has got hours of latency. The hot tier has got milliseconds of latency, so a lot different. We need to think about the costs. The premium tier and premium blob storage and hot tier is going to have high storage costs. We're not going to pay very much to access them. By comparison, the cool tiers and the cold tiers and the archive tiers, we pay not that much to store it. But we got to pay a lot to access it. And then we've got that immutable storage if nothing needs to change. So let's briefly talk about Azure File Storage. And remember, file storage is used when multiple systems have to access the same information at the same time. Typically speaking, we're going to use server message block for Windows systems, NFS for Linux systems, but it can also work with Azure Files REST API. And it can be and this is basically, we're going to create a file share and you mount it on your system. I kind of hope this makes sense. So we might use this to replace a file server that we would have locally. Of course, in the cloud, we could take a virtual machine, we could attach a block storage volume to it, we could share that, and all of a sudden we created our own file server, which is exactly what we do in the data center. We share the server, the hard drives that are in that server. But if you didn't want to manage your file server, this is what we're talking about. So it can be a replacement for on-premise storage. It could replace an on-device NAS environment. It could. Or it could complement your on-premise NAS environments. Remember, NAS is typically cheaper on-premise. It's going to be a lot cheaper than on the cloud. It could be used for developer convenience. It could be highly cost efficient. But we're going to, well, I don't want to say it's cost efficient, but I have to for the exam. It could be considered cost efficient. The reason I say it's not cost efficient, for example, is for $5,000, I have a 96 terabyte NAS device. And I have a second one in Philadelphia. So I've got two of them. The cloud providers wanted $3,500 a month for one. So in 3 months, I paid for all of my storage for the next 5 years. Whereas $3,600 a month for 10 months is $36,000. So basically $45,000 a year for 4 years is 90, so 180,000 versus paying 10,000 to buy the storage myself. So you want to tell me that's saving me money? I got some bridges and some swampland to sell you too. I don't see how there's any savings here, but I have to tell you that for the exam that it might be cheaper. So geographically redundant. So it's going to inherit the Azure's resiliency and the Azure network. And one great thing about Azure File Storage is it's got integrated snapshots and integrated backups and automatic, and that's really great. The way they back up your information in an image file quite beautiful. And with Azure File Storage, your data is going to be it's encrypted in transit via HTTPS. So if it's going from this virtual file server to your system, it's encrypted along the way. And we have to determine how we're going to use it. So we can access it, like I said, we can mount it directly, like on our virtual machines. So there's that. Here's the benefit of using Azure File Storage. You don't have to manage a file server. You don't have to manage your NAS, which means you don't have to patch the software on your NAS. And if and when a hard drive were to actually break on your NAS, which could happen. Remember, mine have a 2.2 million mean hours mean time between failures. So, it's not going to happen that often. But if your RAID array has a drive failure, you're going to have to pop another drive in there. We can basically cache files on premises with Azure File Sync. So we could potentially have our file storage in the cloud, and then in our data center, we can pull this information from the cloud. And when we do that, we can cache it locally. So it's going to give us the flexibility and almost performance of a local file store because we're caching it locally and synchronizing it. But it's going to be really coming from the cloud. We also have to think about our performance tiers. So standard performance accounts use hard drives. They're low cost, low performance. Now we can get better performance if we need it by using SSD drives, which will drive the cost up, but also bump up the performance. But that's only going to be available in certain regions, specifically with zone redundant storage. So let's talk about our storage tiers. Premium, SSD based. So consistent performance, better performance, relatively low latency. Going to be relatively good for intensive I/O workloads like a database or website hosting development. And your only protocol options for the most part when it comes to file storage are SMB or NFS. The two that we use, SMB Windows, NFS Linux. We can also do what's called transaction optimized, and that's going to typically be standard hard drives. And this is basically for transaction heavy workloads without the need for low latency. So we might have to push a tremendous amount of storage, but the latency doesn't matter, like pushing uncompressed video, for example. So applications with moderate performance needs. We may have we have a hot access tier, which is for general purpose file sharing or team shares, like frequently accessed data. We also have a cool access tier here, again, based by regular hard drives, magnetic drives, but they're going to be cost efficient. And the use case here is infrequently accessed data. So we have to determine design considerations wise, what are the needs for availability? Because if we're using an archive access tier for data, it's going to be offline. We have to think about the latency. Premium blob is going to have single digit milliseconds, which is not good, but it's relatively good by comparison to the other ones. Whereas if we're dealing with cool tiers, for example, we may have more millisecond latency. Cost-wise, we have to think about cost, how long we're going to store the cost, how often we're going to access it, that type of thing. And we need to think about it. So, premium and hot tiers, higher storage costs, lower transaction costs. Cool tiers, lower storage costs, and higher access and transaction costs. We also have that option for immutable storage for like banking records or healthcare records that need to be cored. And then, of course, here we've got some other options. So I wanted to put this into a slide that you could see, or I should say Alonzo made this slide look pretty based upon some information I gave him. It makes everything look so much better. So with regards to Azure Blob Storage, this is going to be best for basically read-heavy information. It's object storage, so think big data analytics, backup and archival purposes, that type of thing. And you can see you've got upwards of 20,000 IOPS, which is nothing, by the way, and upwards of 15 gigabit per second of throughput. Now, with Azure File Storage, maybe we need to have 50 servers accessing the same information at the same time. So maybe we've got shared files. It could potentially be a database that's writing to one place and other systems are accessing it. And basically speaking, we've got upwards of 100,000 IOPS, which isn't horrible. It's moderate storage performance. 10 gigabit a second throughput, not bad. Not great, but not horrible, but relatively decent. I mean, pretty decent. And then we have got the Azure NetApp file. So typically speaking, when we've got something like this, NetApp is a tremendously good storage company, and they've got a fully managed enterprise grade NAS type service. So it's going to store on them, and they're going to make it look and feel like whatever you need it to be. And now you've got a big data application like SAP HANA or something that needs lots of performance. Now you're going to get upwards of 460,000 IOPS. And on the cloud, that's going to be pretty darn fast. That'll get you to compare with a local NVMe drive that you would actually purchase for your system. So I think now is probably a good point for us to break, see if there's some question before we get into Azure Managed Disks. With a multi-cloud solution, how do you handle nuances like ingress and egress charges for big companies, as they can be expensive? Do you avoid services? There's lots of things. So first, ingress and egress charges for the most parts have been removed. So the cloud providers typically let you send your data to them for free, but pulling your data out, they charge you. But most of the cloud providers, the big three, stop charging for egress data charges fairly frequently. So if we did a VPN in between them, then across public internet, the egress charges are not there anymore. So there's that. Now, the other thing is, what are we using multi-cloud for example? And what data actually does need to be moved around? And there's lots of options with multi-cloud. We can go true high availability, which is half of your systems in one cloud, half of your systems in the other cloud. And yes, to a degree, there will be some higher data services, but that's going to give us the maximum performance. We can also put our super high performance workloads in our data center, get that direct connection to, say, the cloud providers, private line, Express Connect, Express Route Connect, Direct Interconnect, who cares? There's all these funny marketing names for your cloud providers. And we can pop our really high performance stuff in our data center. And we can run a Nutanix cloud on it, or an OpenStack cloud, for example. We've got everything's functions as a service that we want. We pop that all in the data center. All that stuff is probably a third of the cost by being in the public cloud. And then we can add capacity to the public cloud or fail over to the public cloud if we need. And that's going to reduce our costs even more. But yes, to a degree, there's going to be some additional costs potentially based upon how your networking is and where your transit is and what you might do. So there is going to be more cost for that. But it's all based upon the cost of downtime and what you would actually need. But for the most part, anybody that needs true high availability, because the cost of downtime is too high, will probably be much less concerned about the data transfer costs. But where it's coming down to, David, on the cloud is companies have gotten smart. That AWS cloud practitioner, the cloud's cheaper because of these reasons, nobody believes that nonsense anymore. The cloud providers and their certifications saying the cloud's cheaper, nobody believes that anymore. CIOs have gotten wise. They've looked at their spending bills, say, oh, we were here, and now we're saving money by paying this. So something's wrong. So we have to think about who's leveraging the cloud and what they're getting out of the cloud. They're getting agility. The ability to go from 2 properly managed data centers on Azure to 2 properly managed data centers on AWS at the same time, and deal with, some of the best data center operators in the business who still fail, and going over to the other one is there. The other reason we may go multi-cloud might be this. So who has the most investment in AI technology right now? It's Microsoft. After Microsoft, it's probably Google, and after that, it's probably AWS. So some businesses might want to put their AI in Microsoft. Again, this is not going to enhance availability. Who has the biggest infrastructure of everybody is AWS. So they might put their big infrastructure in AWS. And then Google's got some very things that it does kind of nicely. They may put it there. So we have to understand what's going on and why we're doing it and how we're doing it and why we're doing it. But, you know, if we're going to the cloud, we know we're going to be spending a lot more money. So then it's determining what workloads we probably should put in the cloud. For example, to put it into context, if I had a machine learning application or an AI application that needed 50 NVIDIA H100s, an NVIDIA H100 right now, which is the fastest GPU, it's going to be the 200 really soon for data center workload, is approximately $35,000 to purchase. And if I need them to run 24 hours a day and I buy 100 of them, that's 100 times $35,000. By comparison, if I need 100 of them on the cloud, the AWS charges roughly $45,000 per month for these things. So if I'm going to use it for 3 years straight, I have to pay more for each card every month and then pay that card for 36 months straight. So not only am I paying more each month than each card would cost me, it's going to cost me, basically speaking, 50 times more to run those cards in the cloud. I'm not going to stick that in the cloud. I'm going to do it in my data center. Now, my website, by comparison, where I want that auto scaling, I'm going to put in the public cloud. So a real cloud architect, not like someone that's just been biased by too many certifications, is going to really look at those workloads. And they're going to say, well, we only need these GPUs for a month and a half, so let's stick them in the cloud. I need these workloads to run 24 hours a day, 7 days a week. Stick them in our data center. Well, we've got a lot of storage. Let's take our main storage and keep it in our data centers, but maybe archive some of it to the cloud. So that's really what we're talking about when it comes to the charge. So, if we're really looking to save money, don't go to the cloud. If we're looking for that agility of the cloud, or the fact that we can do best of breed, each cloud provider is better at certain things, again, we've got options there. So it's all about knowing what we're doing and its impact on the business. And that's a great question. And we do need to calculate those ahead of time. Chris, if there's others, we can go there. Okay, no others. Well, then give me a hashtag AZ-305, Alpha Zulu-305 for those of you that are phonetic alphabet fans, and I am, so we don't make mistakes in communication. And then I'll get back to the content. So let's talk briefly about the design for Azure Managed Disks now. We talked about managed files, we talked about blob, we talked about other forms of storage. So let's talk about Azure Managed Disks. And remember, managed disks are block storage. So these are going to be used by virtual machines. And that's typically speaking where our high performance database is going to be. Our static content on our website, for example. And when we're dealing with these, each disk is going to have a maximum capacity of 37.762 gigabytes. So think about that. If that's not enough, what are we going to do? We're going to do RAID. And we're going to add multiple disks together to increase capacity and potentially performance at the same time. Or we can run multiple data disks. Basically, drive 1, drive 2, drive 3, drive 4, drive 5. So there really are options. We can do either. So let's talk about the types of disks we have. So we have the Ultra disk. And we use that for heavy I/O workloads like SAP HANA, top-tier databases, Oracle, heavy transaction. And that's going to give us a maximum throughput of about 2,000 megabit per second and a maximum IOPS of about 160,000. You could go to your local computer store and buy an NVMe drive that gives you 1 million IOPS and 7,000 megabit per second for about $200. Keep that in the back of your mind. But it's going to cost a lot more than that here to rent it, and we're getting about 1/6 of the performance. And that's why we need to know what goes to the cloud and what doesn't. So that's the Ultra disk. That's the equivalent of AWS's provisioned IOPS, what have you. Now, the next option we have is premium SSD. And that's going to be good for dev test environments, production, and semi performance sensitive workloads. We've got about 900 megabit per second. Again, that's about 1/6 or 1/7 of the drive you can buy at the local computer store for a couple $100. And we've got a maximum IOPS of 20,000. So it's acceptable. It's great for a dev test environment, applications that don't require critical performance. And then we've got our standard SSD, which we might use for a lightly used application, more development, more testing. That's going to give us about 750 megabit a second, which is not good, and about 6,000 IOPS maximum. And then we're going to get a standard hard drive. And these are really magnetic drives, and it's great for backup, data that you don't access frequently, non-critical data. And we've got a max IOPS of 2000, which is nothing because it's magnetic storage. But honestly, that 500 megabit per second throughput for magnetic storage, because it's part of a RAID array, is pretty darn good. It's almost the speed of a base SSD. So let's talk about the design for Azure Managed Disks. So we may want to use some encryption. So we've got a couple options. We can use Azure Disk Encryption. And what that does is it encrypts the entire virtual machine's hard drive. And basically speaking, that disk image or whatever you have will only be accessible by the person that owns the disk. So great option. We also have the concept of server-side encryption, and that basically is when it's performed on the actual physical disks in the data center. The data is encrypted in rest and decrypted when we access it. And of course, we have the option to encrypt on the host itself. And basically here we have the data on the virtual machine host that will be encrypted there at rest, and flows will be encrypted to any kind of storage service. But the disks are not going to be encrypted with server-side encryption. The virtual machine host is going to provide that encryption. So what do we need to think about? So we need to think about what kind of throughput we need, what kind of IOPS, and use the right disk accordingly. So if we need anything that's high performance, then we need a reasonable amount of high IOPS and relatively low latency. Our only option is our ultra disk storage. If we need almost good enough, we've got premium SSD storage, which they would tell you is high throughput and high IOPS with low latency. You can make that determination for yourself, but you may use that for a small database. You may use that for a development and testing environment where you need somewhat decent performance, but not full-scale performance. And then you've got your standard SSD, which they consider to be cost-effective, consistent performance. Azure would recommend that for dev test or minor things. And then we've got our standard hard drives for non-critical and frequently accessed environments where we don't need a lot of performance. We might also think about caching, data caching. And by data caching, we can optimize our performance a little bit on read and write access. And we can set the cache settings for the OS disk itself. And that's the default is going to give us read-write control access to the cache. For the data disk, it's going to be read only. So what does that mean? We can cache a little frequently accessed information. So when we need it, we can go to the cache as opposed to waiting for these horribly slow block storage drives. And we really should think about what kind of encryption we need. So we want to use the right level of encryption, and maybe we use a couple of these levels combined at the same time for comprehensive protection. So let's talk about designing for storage security. So we need to do a baseline to figure out what we have. The point of this is to figure out what we have, grant whatever limited access we need. It's going to provide some features for comprehensive security measures to protect our storage accounts. We have the concept of a shared access signature. And the purpose here is to provide a secure delegated access to resources in your account. It gives you the ability to provide control over who's going to access your data. It gives you the ability to define permissions and the duration of the validity of your share. And it gives you the ability to define these access permissions. We can also put firewall policies and rules. So by using a firewall, we can filter who can access it at the network level. So we can restrict access to a specific user's IP address or a range of IP addresses or subnets in the Azure Virtual Network. We can also use a storage firewall to control access to whatever the public endpoints of our storage would be. We may want to use some virtual network service endpoints. And the point here is to restrict network access and provide direct connections to our Azure storage. And we may want to create a private endpoint. And basically what that's doing, if we create a private endpoint, is it's going to enable private access to Azure storages for our virtual network. Maybe to provide secure connectivity between clients that we may have that need it on a virtual network in your storage account. We also want to think about securely transferring our data. And if we use a secure transfer, the point here, the purpose is to ensure our storage account is only going to accept requests from secure connections. And from a configuration perspective, it will reject requests from non-secure connections. And that way it's going to ensure that our data is always smooth and secure when it's transferred. And of course, we want to encrypt our data. So we can use the good news with Azure is data is automatically encrypted. Now, if it's encrypted, we need to think about keys, right? So we can have Microsoft managed keys, and that's going to be the default option, meaning Microsoft's going to manage these encryption keys. We can also have customer managed keys where you can optionally manage your own encryption keys using Azure Key Vault, and that's going to give you full control over your encryption keys. Okay, so now we're going to talk a little bit about databases. So we'll begin this. Chris, I don't think it's been 30 minutes since our last break, right? Or 20 minutes since our last break. I don't think I've seen any questions. So I'll go a little longer and then we'll take a break. So let's talk about design for Azure SQL Database. Remember, Azure SQL Database is a relational database. And because it's a relational database, it's going to be for structured data with a shared schema. Typically speaking, say columns and rows. And where do we use relational databases? Anytime we have to deal with data that's relational to each other, related to each other. And the point here is to glean information. Mike bought this product because there was a 20% sale. Mike hasn't bought a product since there wasn't a 20% sale. Maybe send Mike a coupon for 20% off so he can go spend some money in our store, that kind of thing. So we've got lots of options. We've got the Azure SQL database. We've got SQL database elastic pools. We've got SQL Server on Azure virtual machines. We've got Azure SQL managed instance, and we've got instance pools. So let's talk about the Azure SQL database. This is a platform as a service deployment option. It abstracts the operating system and the virtual machine from you. So it's going to be a fully managed service, and they're going to handle everything like assuming creating this high availability system for you. They're going to tune your data. They're going to back up your data. They're going to patch the operating system of these systems. So all you need to think about is running the database. And if we think about that Azure SQL database, it's going to be pretty familiar to Microsoft SQL. Lots of businesses use for Windows-related workloads, and they have for decades. It scales well, it's intelligent, and it's got high availability SLAs. It's typically designed for very large, it typically auto scales, and it can work with databases that are up to 100 terabytes, which is a pretty big database. And because it is serverless, it can auto scale for unpredictable workloads. And databases are going to share compute and storage resources. So it'll give you the resources that are needed within the limits that you set. Let's talk about, pricing of these things. Well, designed for an Azure SQL database, we're kind of looking at virtual core pricing. So you'll remember when I actually showed you virtual machines and I talked about cores on the CPU, and I told you those cores could split themselves via hyper-threading. That's really what we're talking about here. So when you're buying these virtual machines for your databases, you're dealing with a half of a core. That's called the virtual core. And by doing it this way, you know what you're getting. And for that, so we've got vCore pricing. We also have the concept of a database transaction unit pricing, which is going to be a measure of compute, storage, and I/O resources. It's pretty simple and elegant. You basically pre-purchase something and it's pre-configured for you. We also have a serverless option, which is meaning it's still going to run on a server, but you're not going to know anything about it or where it's running, and it's just going to scale based upon your needs. So you're going to use vCore pricing when you're going to select it, and it gives you the benefit of reserving capacity. But this is great if you know what you're going to need and you're going to pay for exactly what you need because you know it. With this database transaction unit pricing, you're just going to choose a bundle of compute, storage, and I/O resources, and it's going to be a pre-made plan for you to use. Whereas the serverless option is you just pay for what you use. Now they charge you quite a bit for what you use, generally speaking, in serverless. If you use it a lot, it's going to be prohibitively expensive. If you use it very little, it's very simple. So there's that. And of course, we also have the option for these elastic database pools, where you're going to buy a set of compute and storage resources and share it amongst your databases. So that allows every database you have to use resources as needed and share back and forth within your set limits. So let's talk a little bit about this platform as a service deployment option. It's fully managed for you. So you're not patching the operating system on your virtual machine. For example, you're not patching your SQL. It's there, it's ready. It's more about your data. So this could be used in a lift and shift migration. Why? You're moving your SQL data to your next SQL data, and you're doing it. And it's going to be fairly simple to use. We can allocate resources based upon vCores if we needed to define maximum CPU and storage. And most features that will be available in SQL Server, the traditional one you run on your servers, are going to be available in SQL managed instance because it's basically a Microsoft product, and where they put it is irrelevant. So there is that. We can also think about instance scope features. So maybe we need to utilize features like a service broker or a SQL Server agent or link servers. And we're thinking about the scalability of these things. So how many CPU cores do we want to define as a maximum for our storage? And that gives us the ability to basically make sure we've got resources. Now let's talk about running the full version of SQL Server on an Azure Virtual Machine. And by doing so, this is basically identical to what you have in your data center. So your CPU cores and your DRAM are going to be there. And here you've got more control. You can lock out a certain amount of performance. You can determine what your drive storage performance needs ahead of time. You can make it any way you want it. Their specific version and OS, anything you need. So now you've got the best and fullest capabilities because it's a full install of Microsoft SQL Server. Guess what? The people in your data center that have been managing SQL Server for the last 20 years will use the same interface and nothing changes on the cloud. But Azure can automate your backups and your security patches if you want. But users are responsible to update versions of the operating system and, generally speaking, SQL Server, because this is a normal install the database on a server, just like you've always done in the data center. It's going to give direct access to the server, and it really gives you the same equivalent of your on-premise Windows SQL Server. And potentially, if you've already got licenses for your SQL Server, it'll reduce your cost because you're already paying for it. So Alonzo drew this great graphic. I think it'll help. So we can use the SQL database, which is basically an environment where it's simple, it's serverless, and for the most part, you don't have to think about it. Just does what it's supposed to. We can do SQL managed instance, which is basically a semi-managed environment for you. And we can also go to that SQL on Azure Virtual Machines. And that's the identical SQL server that you've always used. You've got full operating system access. You've got full control. You've got full performance tuning, and there's nothing holding you back. So what do you need based upon the business? But for the most part, you can use any that you need. Each one has its trade-off. More control on a virtual machine. Serverless, you lose all control. But you don't have to think about it. You don't have to know as much. So whatever is best for the business. So let's talk a little bit about scalability. So we have to think what we're dealing with. When we deal with Azure SQL database, it dynamically scales for you. Adds CPU power, memory, I/O, throughput. Not in the virtual machine version. You're going to have to manage that. But in these more serverless-oriented versions, you're getting that. And then it's about what your resource models are, if your characteristics for dynamic scalability. Are you doing this database transaction unit where you define the maximum amount of resources you need? Or are you doing it via virtual core? And that'll give you greater control because you're basically specifying a certain amount of compute capacity that you have. You may want to do some kind of elastic database pools where basically we can purchase resources for all of our databases in a group, and then they can share within them. We have the option for vertical scaling, meaning bigger server. Horizontal scaling, adding things like read replicas, what have you doing, or partitioning your database or sharding, that kind of thing. Some things we should think about with regards to our databases is, maybe we've got multiple databases with various resource requirements. And if that's the case, maybe this concept of an elastic database pool with vertical scaling is going to be great because we can make sure that all of our performance resources are available when needed. We've got a predicted budget, and we don't have to worry about per charges per database. We could also think about geographically distributed databases and horizontal scaling. So maybe we're going to split our database into multiple different databases, and that way they can scale independently of each other. It's an option we could have. What if we need to deal with business intelligence tools and data integrity tools? Well, that's where we get into these elastic database tools and things like Elastic Query. And the benefits that provides is access to the query of data across multiple things using something called TSQL. And it's going to integrate with tools like Excel, Power BI, Tableau, so you can really visualize what you're getting these business intelligence reports. And that's going to be available in the standard tier. Bear with me one second. A little bit of allergies from my cat sleeping on my head. So when we think about scaling our databases, we need a solution. If we think of vCore service tiers and the architecture for high availability, we think about it. And then we're going to have various service tiers: general purpose, business critical, and hyperscale. Well, think about it. Hyperscale, very big business. Business critical, critically important, super high availability, good performance. General purpose, not so much. So think about these options that you actually have based upon what you're actually going to need. So general purpose is going to be remote storage with locally attached SSDs. And the data and log files will be stored in Azure Premium Storage, which will be locally redundant. And our files will be backed up with Azure Standard Storage with that geographic redundant storage. Let's talk about, the failover that's based upon that. And that's going to be built on Azure Service Fabric, and that's going to provide that automatic failover. So here's going to be the failover process. It's going to locate a node that's got spare capacity. It'll instantly spin up a SQL Server instance. It'll attach your database files and run that kind of recovery. It'll update the gateways or anything you have that's going to point to that new database node. And basically, it's done. It's simple. No virtual network, no listener updates are required. Now, when we deal with this business critical availability, it's going to be a little different. It's going to be similar to an always-on availability group, The data and log files run on directly attached storage SSDs. That means much less latency. There'll be 3 secondary replicas. One of them can be used as a read-only endpoint at no additional charges. And the transactions commit when a change to at least one replica makes a change. So you change it, it's going to push it out to everything else. Now, this is going to give you very good performance because it's locally attached storage, and it's going to be great for mission critical. So if you think about it, when I talked about that $200 hard drive giving you better performance than block storage, now you understand why. And of course, we've got the hyperscale availability. Now this is great for really high performance databases. So we're going to have lots of caches around and page servers for quick access. We'll get some horizontal scaling of page servers. We can deal with a database of upwards of 100 terabytes. We're going to get near instantaneous data backups in the form of snapshots. Basically, it creates an image file. Got really fast database restores in a matter of minutes. Scale up, scale down in a relatively consistent and low amount of time. So when do we use all these? When do we make this determination? So for general purpose, it's going to give us that balanced compute and storage. So Alonzo drew a beautiful graphic on this. I think this is going to help you. So the general purpose storage, which is going to be your standard or basic, is going to give you balanced compute and storage options. Not the best, balanced. Business critical. Now you're getting into premium environments and tiers, and that's going to give you lower latency and higher resilience to failures. We talked about why that actually occurred. And once we reach hyperscale here, now we're in a totally new world. Large databases, 100 terabytes. Read replicas. There's lots of caching in there, lots of good performance, and that's really what we're talking about. So what does the business need? So let's talk about designing security for our, actually, I'm going to stop there. That's a great place for questions. And then we'll go into security for data at rest and data in motion. So let's see if anybody brought in any questions. Everyone's awfully quiet today. I'm either doing a perfect job explaining everything, or you all know it, or people are shy. So don't be shy. We want to do anything we can to help you. So while I wait to see questions, I want to remind everyone that at 5:30, we have an opportunity for you to ask any career questions you want on Zoom. Can you operate a global website with low latency without a cloud provider? Yes, absolutely. If you have your own premise DC in one location. So if you've got your own on-premise data site or data center, and you have more than one internet service, right? Let's talk about availability. So all you really need to host a website, you could literally do it in your house. You could get DNS matching a public IP address to your you got a static IP address. You could set up a DNS policy that maps whatever domain name you want to your IP address. Pop your virtual machine or multiple virtual machines in your house, or a single virtual machine, and you've got a web server and it's up and running. So you don't need a cloud provider at all. Now, that's not going to give you high availability because your home internet service provider is not. Now, what most people would do and most businesses do for their websites is they typically go to a co-location center, which is typically going to be much cheaper than a cloud. Well, a lot of businesses do. And a co-location center is a managed data center for you. You basically rent space on a rack where they rent you a virtual machine like a cloud provider. You put all your stuff on there on your virtual machine. You create a route to the internet. You create your demilitarized zones with your firewall and block everything you need to and limit what you need to. And boom, guess what? You now have a website. And you can connect that with the content delivery network of your choice. Most people would use Cloudflare or Fastly or Akamai. There are some of your biggest content delivery networks in the world, and you're good to go. And that's what we've done for the last several decades. Or you could go to your own data center. Your own data center, you could say, oh, wow, we're going to connect to 4 different internet service providers for redundancy. We're going to have really good controlled environments. We're going to have our network in a completely redundant environment, our power in a completely redundant environment, our cooling in a completely redundant environment. We're going to put mission critical enterprise grade security, and you're going to have a very secure website. And truth be told, if you put that in 2 different data centers and they're properly run, because you've got good data center people, you're going to get everything you got on the cloud provider with less things to go wrong. Why is it less things to go wrong? Excuse me. Well, in the cloud provider, they're hyperscale, so they got 1,000,001 of these systems in there. They've got this enormously complicated control plane that they have to deal with, and they're so big that there's just more things to go wrong. In your data center, you can add a lot more network security, which you can't do in the cloud. In your data center, you have the ability to prioritize traffic, do all kinds of forms of admission control, and you'd be just fine. So yeah, you don't need a cloud provider to do anything. You'll probably get lower latency before. In fact, Freedom Lands, you may have noticed about 10 to 15 years ago, you went to a website like a travel website like Expedia to book a flight, you entered your information and poof, it was there, or any of these airlines. And you can see after they went to the cloud and they dealt with higher pricing and cloud storage, which is slower than data center storage. Now you go to a travel website, you enter, I want to leave Palm Beach to go to Philadelphia, you click, and it spins around for a little bit. So all in all, you're not getting any lower latency on the cloud. And why is that? Well, the storage on the cloud is slower, and now you're in a shared network. So most likely you'll get better performance not using the cloud, less latency not using the cloud. You don't have auto scaling on the cloud, and you got to buy your stuff on the cloud. But yet you don't need a cloud provider at all. We've done it for decades without cloud providers. And some of the biggest businesses in the world are still not on the cloud. In fact, less than 50% of the companies are not out there are even using the cloud. And the cloud is great. I love the cloud. The agility of the cloud enables medium-sized businesses to, realistically speaking, deploying new services fast and compete with bigger entities. It's great. Now, at the enterprise level, where they've got the sophistication and the personnel to do it, they may save money by having a private cloud and still leveraging the public cloud. But yeah, you can do all this stuff without the cloud, and we've done it for decades. You can do it on the cloud. Remember, Freedom Lands, the cloud is a virtual version of the actual data center. So virtual. So you can build your own house and it's yours. You can go to a hotel and rent a room and it's yours temporarily, but it's really the same thing. Good question there, Freedom Lands. In JDF Trades, I completely agree with you. Hosting your website on the cloud provider in many cases will cost much more compared to native hosting offerings. But here's where it doesn't versus here's where it does. If I've got a consistent website that has predictable capacity all year long, and I already have a good network, and I already have good security, and I have everything in place, it's going to be substantially cheaper to run that website in the data center than the cloud. It will, typically speaking, give me better performance, and all that's simple. Now, here's where it doesn't, JDF Trades. Now I've got a retailer, and that retailer, by comparison, needs about this much capacity most of the year and this much capacity during peak times. So what do we do in the data center? We typically build for this, and then our systems do nothing all year long. So for a very giant environment for a website like a global retailer, that might be cheaper to potentially put on the cloud and run at very small capacity and then add auto scaling when needed. But Generally speaking, anything on the cloud is going to be more expensive than the data center. And it has to be, because you have to understand this. They have to build the same data center that you would build. Then they have to pay the people to run the data center just like you would. So it can't be cheaper there. The next thing they need to do, these companies have to hire 50 to 100,000 salespeople. That means solutions architects, account executives. And if you look at 100,000 people with a fully loaded salary at the cheapest of $250,000 a year, you got to pad that in there. And then the company has to add a profit margin before they sell it to you after paying the people. And they can't do it for the most part at a lower cost than what you have. Now, there will be various use cases where it's cheaper. There will. And there'll be various use cases where it costs 5 and 10 times more. But that's why the analysis needs to occur. And that's why these hybrid solutions where you leverage the best of both and these hybrid multi-cloud are really what big businesses and enterprise are using. Because they know they can do a lot of things better, faster, and cheaper than in the cloud. But they know there's some things that they can't do anywhere near as well as the cloud and be agile. So yeah, that's why it's not like in a certification. There's a big real world component that's so different. So I hope you all have had a good time. I'm going to stop here because we're less than 10 minutes away from what it used to be, from when we were going to finish. We will be back at 2:00 tomorrow for this training, but in 38 minutes, we're going to come live on Zoom. We're going to get into career stuff. That's really where we specialize, architecture and careers. And we're going to be there free for you. And for the first 45 minutes to 60 minutes, I'm even going to bring my chief technology officer, Mark Milovanovic, who is a rock star with tech. And for those of you that are looking for more technical things, then he'll be there, like more technical, more engineering careers. For more architecture related things, you've got me, because I've been building architecture careers for the last 25 years or 20 plus years. Take care, everyone.